Good evening, all of you. Welcome back to one more session of your WOC. This is your Vani ma'am, your world of chemistry. Yes, today the chapter which we are going to start is amines, the compounds or the molecules containing nitrogen atom. Yes. So these compounds we are going to study this chapter. Most important, this doesn't have any mechanism, so no problem at all. We basically have important reactions like the diazotization reaction, coupling reaction with Hinsberg reagent, few things, carbylamine reaction, easy reactions all. But important thing is this chapter has paragraph based questions like A reacts with so and so, so then forms B reacts with so and so, then forms C. Like that, identification based questions are maximum asked from this chapter, and that too a 5 marks question. So without wasting time, let's start the video. I request all of you to go into 2024-25 playlist. Reason, I have sent all the chapters, basically line by line NCERTs taught by me. All the questions starting from your MCQs 1, 2, 3, 4, 5, everything is solved from my end. So World of Chemistry is a complete package platform where you have sessions for grade 10th, 11th and 12th. Especially those who are writing your board examinations, your one-shot videos are damn sure. There are beautiful videos like finding log without log table and everything. So as I said, please go and watch and check 2024-25 playlist where you can find all the chapters, all the 10 chapters which you have for your board exams. So without wasting time, I request all of you to watch the complete video, take a long notebook and start noting and learning. As I mention always, there is a new motivation channel also which Vani ma'am has started. That is Motivation with Vani Putepalli. There we are going to learn or listen to loads and loads of stories that are but after exams. Okay. So now this in the description, Telegram channel link is given. Please join. There are a lot of notes also which are sent in the Telegram. Chalo, without wasting time, let's start the video. Any doubt, any point of time, please ask me. Thank you so much. All the best. All right. Welcome back students. Welcome back to your next chapter, and that too we are going to do your boards 2025 preparation. Yes, a complete organic chemistry revision series. When I say revision series, it means it is line by line. Yes, we are going to do in detail. I'm going to teach you the topic. I'll be doing the questions. You'll be understanding and you'll get wonderful marks. Chalo, let's start today with the chapter which we are going to do. On before that, as you know, we have completed haloalkanes, haloarenes. It is kept in the playlist. Alcohols is done, aldehydes is done. Today we are going to do amines chapter. The weightage of the chapter is 6 marks. Okay, so total are 33 marks. I'm sure these 33 marks are ours. Okay, chalo, let's start the amines chapter. Amines, as I said, in this particular year, academic year, as you have written your physics paper also, we very well know the 33 questions. All in that 16 are MCQs, 5 are short marks, 7 are short, very short answer, 2 case based and 3 long. Not to worry, we are going to deal with all this variety of questions. Alright, let us not waste time. This is your Vani ma'am, this is your world of chemistry. Let's start the video. For certain things to save time, I'll just show you certain pictures and then I will explain in detail everything. Ciao. So, nitrogen containing compounds, amines. So basically I'll be doing such questions where NCERT page number will be mentioned, where I have taken the question, how the question is going to ask. So we are going to deal in detail all the topics. Wherever it is required, I'll explain. Wherever it is not required, I'll going to show the things. Ciao. So in this particular chapter, we are going to study nomenclature, classification, structure, methods of preparation, physical and chemical properties, uses, identification, everything in depth. Okay. First of all, as I do before examination, time will be less. Correct, no? So I prepared for the whole chapter 1-page revision. How? Like this. See this? This is completely 1-page revision. Preparation of amines all on one side and your reactions of amine all on one side. See, the whole thing is come under 1 page. So I believe in 1-page revisions during exams. Correct? If you prepare this 1-page revisions, what will happen? You can apply this concept in your questions. Questions is important. The studying, this is not important. Applying in questions is important. So for the whole chapter, I'll give you such things and not to worry. So let's start the video. First of all, your organic, as I said, a few things to save time. I will show you the images. Few maximum I'll explain. So basically your nitrogen compounds are what? Nitrogen compounds, they include amines. In that amines you have three varieties. 1 degree, 2 degree and 3 degree. 1 degree means what? There are 2 hydrogens. 2 degree means 1 hydrogen. 3 degree means no hydrogens. Nobody will ask you this question, only for your understanding. Nitro compounds, they are both aliphatic and aromatic nitro compounds, NO2 group. There is one more category, cyanides, where CN is the functional group. Next, isocyanides, where NC is the functional group. Nitrites, that is RNO2 or RONO, this is one category. Then last but not the least, aliphatic and aromatic diazonium salts, that is nothing but your BDC, benzene diazonium chloride, in that way. So these are the different nitrogen containing compounds which we have. Alright. So what is going to ask? They will not ask anything from this, but simple for us to understand these are the varieties. Okay. Next thing, as I said, what are amines basically? Amines, if I have to start from the basic scratch, I am studying today only, so I have to understand what it is. Nothing. See, amines, if I have to talk, amines are, they are both, I can call them as alkyl or aryl derivatives of ammonia. Alkyl or aryl derivatives of ammonia. Ma'am, what is this alkyl or aryl derivatives of ammonia? That means if I have ammonia like this, see this, ammonia is NH3 formula, na? Ammonia, not ammonium, ammonia. Now what will I do? I'll take out one hydrogen, I'll add one alkyl group to this. So what will happen? R, now this is there, right? Here R has replaced one hydrogen. In the left out are only 2 hydrogens. Now I'm going to take out further hydrogen and add one alkyl group. Now alkyl group is increasing, number of hydrogen atoms are decreasing. Further I'm taking out one more hydrogen, I'm adding one more, R2 will become R3 and N. So the one which has 2 hydrogens is called 1 degree amine. Okay, the two alkyl groups are 2 degree amine and 3 alkyl groups are 3 degree amines. Okay, now here alkyl and aryl derivative means same thing, but what did we do? I have derived the amines from ammonia. That's why I said amines are alkyl or aryl derivatives of ammonia. I pulled out amines by replacing one hydrogen with alkyl. So there are alkyl or aryl derivative. Aryl derivative means aromatic ring, which I'll show you. Is it easy? Easy. So first question is over. Now there are certain questions in the board where they're going to ask you about uses. So this table I have given you, just remember adrenaline, these are all aromatic amine compounds. So adrenaline, ephedrine, novacin, benadryl, nicotine, trimethylamine, what are the uses? You study this, because they may ask you what are the uses of nicotine as a compound which belongs to the nitrogen group. Like that, prepare this uses. It is very important. They'll ask you for 1 mark. Okay, 1 mark. Now, like this uses, there is one more important thing which you should remember is uses of amines in biomolecules. So, biomolecules, what are the different biomolecules? Biomolecules are proteins, which we have studied in biomolecules chapter. Okay, biomolecules are vitamins. Okay, biomolecules are alkaloids, correct na? Large molecules rather, biomolecules are hormones. Okay, so all these are biomolecules. So what is the role of amines? Amines are going to act as intermediate. Okay, even polymers are there, big molecules, polymers are there, drugs are there, dyes, all these biomolecules. Yes, to prepare all these, your amines whatever are there, they are acting as intermediates. So this is the use of your amines. Okay, just remember this is only a 1 mark question. Okay, leave it easy. Now we will see the classification. As I said, to save time, few things I'll be showing it to you. Let's start. So I know what is meant by amines, what are the uses. Now classification of amines, careful, gradually we'll go one after the other. So what is required? Concentrate, students. Now classification of amines, this is a tabular column which will save your time. So in your classification of amines, remember, first I said amines are of 1 degree, 2 degree, 3 degree and 4 degree. What is 1 degree? 1 degree is which has 2 hydrogen atoms, correct? And same thing, this is tertiary butyl amine. Tertiary means there are no carbons with hydrogen, no hydrogens with carbon, but there is an there are two NH2 groups with that. Got it, students? So you should carefully understand, if there are two hydrogens with nitrogen, then it is primary. Don't go with the carbon atom, go with the nitrogen. So this is also primary because it has two hydrogen. In secondary, there is only one hydrogen attached with nitrogen. We call it as dimethylamine. In tertiary, there are no hydrogens with nitrogen. So your concentration is check for nitrogen and then the hydrogen attached. Don't go with the carbon. Trimethylamine means no hydrogens at all. In quaternary, just check carefully. Nothing. You have, and quaternary are basically salts, ammonium salts. So they are going to in them, because there are no hydrogens, they combine with your salts and then form tetramethyl ammonium bromide. So basically quaternary are salts. We are not going to do much here. Simple to understand. Now secondary amines are also divided into two types. One is simple or symmetrical amines and mixed or unsymmetrical amines. So what is this? In simple symmetrical amines, just observe, both the alkyl groups are same. So I call it as diethylamine. Now in mixed, one side is ethyl, one side is methyl. Means it can be different. Propyl, butyl, pentyl, propyl, like that. So in mixed or unsymmetrical secondary, the groups are different, but there is only one hydrogen atom. So secondary means only one hydrogen atom. Next comes your tertiary. Tertiary, same, symmetrical amines where all the groups are same and there is no hydrogen. In mixed, symmetrical, the alkyl groups are different and there is no hydrogen. Okay. Unsymmetrical means same alkyl groups. Unsymmetrical means different alkyl groups. Correct na? Yes. So alphabetical order: ethyl, dimethyl, amine. Okay. Easy. Just to understand. Now clear, students? So primary, again secondary into two types, tertiary into two types, and quaternary. So this is for your understanding. Now further classification, if I have to understand, careful, this is aromatic amine classification, this is aliphatic amine classification, and this is aromatic amine classification. Once again we will understand, and we are going to apply all this in the nomenclature. See, aryl amines and aryl alkyl amines, two categories. Aryl amines means what? Nitrogen atom is directly attached, bonded to aromatic rings. Everywhere nitrogen atom is directly bonded to the aromatic ring. Here aryl or alkyl amine means nitrogen atom is bonded to side chain. See this? Bonded to side chain, bonded to side chain, side chain, bonded to side chain. Is it okay? Chalo, let us understand. So aryl means directly it is attached to the ring. So if there is only one amine group, I call aniline. There is here in primary, there are two hydrogens here. Here in aryl amines, where nitrogen is directly attached but there is only one hydrogen, then I call diphenylamine. It is 2 degree. Two things you should remember. In tertiary, there are no hydrogens and there are 3 rings. I call triphenylamine. Clear? Simple? Simple. So primary aryl amines means directly attached with 2 hydrogens. Secondary aryl amines means directly attached with 1 hydrogen. Tertiary means directly attached with no hydrogen. Okay, done. Next comes aryl alkyl amines, where indirectly nitrogen is attached. In this we have 3 varieties: primary, secondary, tertiary. In primary, what will happen? It is, first of all, it is indirectly attached with 2 hydrogens. Secondary, indirectly attached with 1 hydrogen. Tertiary, indirectly attached with no hydrogens. So if it is indirectly attached, it is called with aromatic ring benzylamine. Here dibenzylamine. Here tribenzylamine. So it's clear, students? Aromatic, careful. Aryl amines and aryl alkyl amines or aryl alkyl amines, anything. Is it okay? Easy. I'm going to apply this all, and further they are simple, mixed, simple, mixed, simple, mixed, simple and mixed. I'll show you all in the nomenclature. Shall we start naming it? Chal, let us start. First thing, nomenclature of primary amines. I'm going to take and explain it. Careful, understand. So we are talking basically about your aliphatic amines. Okay, aliphatic amines. So aliphatic amines are named. How are they named? When you are naming it, first comes your, there are 2 things. One is your common name, correct na? and one is your IUPAC name. I'll explain in detail, don't worry, all we are going to solve the questions also. IUPAC, and first understand the concept. In aliphatic name amines, first comes your alkyl group name, whatever name of the alkyl group, then comes your amine group. For example, I take CH3NH2, easy. What do I call this? First common name, methyl amine, correct na? IUPAC name, I'm calling it as methanamine. Myth instead of il, I'm going to replace with a, methanamine. Is it okay? Easy. Now let us take the second one. The students who are starting today also, this video will be helpful. The students who have done completely, this is completely one perfect revision. Ethylamine. Here what do I call? I call it as ethanamine. Oh, is it okay? Done. Next, I'm going to take your molecule in this way. Now what do I call this? Like basically if I call like this, secondary. So I call it as ethyl. Why ethyl? See this. Ethyl, methyl. This two carbons na. So ethyl, one more methyl amine. Correct na? Now what do I call? Because it has only one hydrogen atom, then I call it as N-methyl, alphabetical order, ethanamine. And what is this N? I'm going to show you further in examples. You will further understand what actually is this. So go back. Let us go back, and whatever I did, let us see in a tabular column. Now you will understand. Same thing in a different way. See this. One carbon atom, common name, methylamine, methanamine. Okay, studied. Ethylamine, two carbon atoms, done. Three carbon atoms with amine, N-propylamine. In common name, we are going to write it as N, normal chain. In IUPAC, we are going to denote the position of the molecule. So, amine, always as I said na here, first comes your alkyl group, then comes amine. So, when you are naming it, first propan, one amine. Easy. Now come to this. This is an iso group na. When you have something in the T-shaped form, this is an L-shaped inverted L. It is called iso. Now how many carbons are there? First it is isopropylamine. First comes alkyl group, then amine. Now 3 carbon atoms, propan, 2 amine. Position, everywhere position we are naming. See this molecule, 1, 2. 2 alkyl groups and 2 amine groups. So what would I do? First start with your alkyl group, ethylene diamine. Nobody will ask you common name. They'll ask you IUPAC name. Now see this. How many carbons are there? 2 carbons. So ethan, 1, 2 diamine. Easy. First alkyl group, then the amine group. Okay. Next comes. Here there is a double bond. Nothing. As we all know, a functional group is attached to a carbon, then to the double bond is always allyl. We have been studying this. Na? So common name I call it as allylamine. Now give it a IUPAC name. From where should I start? First I have to write the parent chain. How many? Prop. Then comes your double bond. 2 ene, 1 amine. Correct na? Prop, 2 ene, 1 amine. Easy. Next, this particular reaction you all know. Aniline or phenylamine, phenyl group. Aniline or benzamine. Benzamine. Actually benzene amine. Okay, easy this is. Next comes your NH2 and CH3. Now careful. This is your ortho position. Correct na? This is your ortho position. This is your meta position. This is your para position. Meta, ortho, para. Now in common name you name it as orthotoluidine. But in your IUPAC you will mention the structure, or you will mention the position, that is 2-aminotoluene. 2-aminotoluene. That means when you are doing your aromatic compounds, you are trying to name the amine group first and then the functional group. Correct na? Ma'am, shall we do some questions? Let us do some questions and understand this. Now, they are asking me to draw the structure of the following compounds. N-isopropylamine. What is this? N-isopropylanilene. Okay, first one we are going to write. N-isopropylanilene. So iso means I told you na, CH3 in this way, L shape. You should know this iso group na. So let us draw. But here aniline is there. So first I will make an aromatic ring. Okay, aromatic ring I made. Then I should make N. That means there is only one hydrogen atom in that. Isopropyl group, 3 carbon atoms and aniline. Easy na? Very easy. Correct? Now tertiary butylamine. Tertiary means what? There are no hydrogens. So carbon with 4 alkyl group in this way, and my NH2. So this is your tertiary butylamine. Easy, easy. Next question. Let us see. Now same thing. These are all aromatic and aliphatic. Suppose if they ask you simple in cyclo group. So this is one question. Now let us see this. What is this molecule? Earlier I did aniline, but here there is no aromaticity. How should I call common name and my IUPAC name? Okay, now common name, there is no aromaticity, so it is a cyclo group. How many carbons are there? Hex. Alkyl first comes hexyl, amine, correct na? Now IUPAC name, it is cyclo. You go to name it as amine, hexanamine, hexanamine. You see? Now tell me this, students, tell me this. I made this molecule CH2NH2. Now tell me, this is directly not, it is not directly attached to the ring, but there is an alkyl group, so can I write it as benzylamine? Okay, now IUPAC name, this is a phenyl group, so we are going to call it as phenyl methanamine. So in aromatic thing, you're going to draw the parent chain, then comes your amine group. Okay, we'll try one more question and see. Write the IUPAC name of this. Okay, ma'am, there are nitro group. First of all, nitro groups and amine groups. It's okay. This is IUPAC name, means you should always write the position of the molecule. How should I start numbering position? 1, first comes the amine, 2, 3, 4, 5 and 6. So write down 2, 4. Sorry, 2, 4, not hyphen. Careful students, don't write wrong. 2, 4. Okay, next dinitro. Right, dinitro, 2 nitros are there. Benzamine. Okay, you can also write 2, 4 dinitro aniline. This also works. This is also correct. Easy, easy, very easy. Now we studied the primary, we studied aromatic. Now we are going to see the secondary amines nomenclature. Secondary amines with what? There is only one hydrogen. Now see this. So this is your common name and this is your IUPAC name. Alright. Now check carefully. In secondary amines, there is only one hydrogen with nitrogen. Okay. Now, if there are 2 methyl groups, I call it as dimethylamine because 2 methyl. But when it comes to your IUPAC, carefully observe. In secondary, you are going to name it with N, capital N, methanamine, because both are same. One capital M, capital N, capital M and small. N-methyl-methanamine. Okay, suppose there are unsymmetrical in this way. This side ethyl group is there, this side methyl group is there. Then how should you name it? Okay, a common name is alphabetical order ethyl-methylamine. It's okay, alkyl amine. But again, N means one hydrogen. First comes the alphabetical order. Careful. M, A, B, C, D, E, M. Ma'am, E comes first, na? Alphabetical order, that's the difference. In IUPAC name, here common name, first comes this. But in IUPAC name, the smaller group comes first and the larger group. Is it okay? In IUPAC name, the smaller group comes first and larger group. Let us see the next one. 2 rings are there. So diphenylamine. Now, when you are naming it, just see. Diphenylbenzamine. Diphenylbenzamine. Is it okay? Easy. I am going to apply in the questions and show you. Further we will see. This is secondary amine. Now we will see tertiary amines. Now observe tertiary amines. In tertiary amines there are no hydrogens at all. But if you have 3 groups, you call it as, means tertiary means you name it as N, N. If it is secondary, you will give it as 1N. If it is tertiary, you are going to name it as N, N. Dimethylmethanamine. Correct. Next, N, N. Diethylethanamine, because all are ethyl groups. Next, N comma N, dimethyl ethanamine. The smaller group is coming first. Next, N comma, now here you have your ethyl group and methyl group. Now here what did you do? You have different things, so you have differentiated into N-ethyl, N-methyl ethanamine. Okay, N-ethyl, N-methyl ethanamine. Is it okay? Easy? Easy. Chalo, careful, because you separated into two different, you are naming it as separate compounds. Is it okay? Yes, this is ethyl, first thing, because the group is different. Then N, and then N-methyl, the smaller one, and then the larger one. Is it okay? Chalo, this is taken as a substituent of that. Chalo, next further we will see. Now here, this is tertiary, so N comma N. Now, how many groups are there? Substituent, dimethyl benzamine. Is it okay? Yes, clear? Everywhere I'm same concept. Smaller group, dimethyl benzamine. Now see this, aniline comes first. 2, 3, 4, 5, 6. So 4 bromoaniline or 4 bromobenzamine. Last, this is tertiary, so N substituent benzyl. This is one part, and the second part is N-methyl smaller group benzamine. This is second part, N-benzyl hyphen N-methyl benzamine. Clear, students? Easy. All right. So basically remember. 1 second, student. My writing pad na, it bothers me sometimes. I don't know why. It is lazy. It doesn't want to write. Okay. So sorry. 1 second, students. I'll set my writing pad. Yes. So remember, when you are doing your, okay, again it is giving a problem. Sorry for the inconvenience. Whenever it is secondary, careful. You are going to represent it with secondary amine with N. When it is tertiary, you are going to use the word N comma N. Okay, easy. Chalo. Let us do one thing. Naming of aromatic compounds. So simple. Suppose, before we go to the question, before we do this question, simple aromatic. One example I'll take. You know, this is one common thing which we are going to do. This is nothing but aniline or benzamine, correct na? Aniline or benzamine, easy. Directly it is attached, so I used it. Suppose I have an amine group and a methyl group in this way. I have amine and I have methyl group. Where should I start? Always amine gets first, correct na? Always amine gets first. So IUPAC is 2-methyl amine. 2-methyl amine. Easy, like that. Simple. I will do the positions. Now let us see this question and understand. Write the IUPAC name of the following. Now as soon as you see this, go and concentrate on N. N is tertiary, secondary or primary? Tertiary. Okay. Now what is the parent chain? See, these are all substituents. So parent chain is 1, 2, okay, 1, 2, 3, 4, 5. Okay. So 5. The longest one is 5. Correct na? Alright. So start first. Methyl group should be substituent na? So at the third position you have methyl, correct na? The third position when I start naming 1, 2, 3. Okay. Then next is, because it is tertiary, I will write N comma N. To the same N, what groups are there? What groups are there? 2 methyl groups are there. So it is dimethyl. Okay. What is the parent chain? Pentanamine. Dimethyl pentanamine. Now how did I get 3-methyl? Now this part is clear. Dimethyl pent carbon substituent. See this 1, 2, 3, 4, 5. So this is first position, second position, third position. So this one you have a methyl group. So I've taken the longest chain. Okay. Next question. Write the IUPAC name of the given compound. What is this compound? Easiest question. Nothing. 1, 2, 3, 4, 5. Basically 1, 2, 3, 4, 5 and the sixth one. Correct na? Sixth. So basically what did I do? The carbon 1, 2. This I missed na? 3, 4. This is 5 and 6. Okay. This is 2, 4, 6 tribromoaniline. Tribromoaniline. Easy when things are very easy. Yes, easy. But for all those who are watching for the first time, it should be easy. For all those who are studying for the last time, easy plus difficult. Chalo, let us make this. What did they ask me? Draw the structure of, or write the structure of N-methyl ethanamine. N-methyl ethanamine. So first one we'll do. Do I have place? I don't have place. First one. N-methyl ethanamine means N. Primary, secondary or tertiary? Careful, it is secondary. Methyl ethanamine. So try to make first ethyl. Then make N. Correct? Then methyl. That's all. Easy. N-methyl ethanamine. N-methyl ethanamine. Next one. Draw the structure of amino-toluene. 2-amino-toluene. So toluene group is the main thing. In the second position I have amino. Easy? Okay. Third. Give the IUPAC name for this. So you only tell me what is the parent chain. Parent chain 1, 2, 3, 4. Bute. Okay. Bute. In that bute, first double bond is given preference. Na? So at which position? 1, 2, 3. After third carbon you have bute. 3. After third carbon 1, 2, 3. After third carbon you have 3. Ene. In the first carbon you have your amine. 1 amine. 1 amine. Easy? Very easy. The fourth one. Write the structure of NN. So this is primary, secondary or tertiary? Tertiary. Correct? Na? So tertiary N. 1. Ethyl methyl amine. Ethyl methyl amine they said. Okay, N comma N. Then tertiary there are no. So one second. What did they ask me? N comma N. Ethyl methyl amine. Okay, they asked me ethyl methyl amine. So but here what happened? To satisfy the valency, I made it. Got it, students? Easy? Easy? Chala, easy. Next question. Write the IUPAC names of the following. Okay, what is this IUPAC? There is a double bond. There is this also. Okay, same, almost similar. How should I number? 1, 2, 3. Correct, na? But here, what is the parent chain? Simple. I can start from here. Then I'll get a longest chain. 1, 2, 3 and 4. So the parent chain here is bute. Bute. At the which position you have double bond? 3. Ene. 2. Amine. You see? Now name this compound. This is which group? This is which group? There is only one hydrogen. So it is N. Which is this group? Phenyl. Phenyl. How many carbon atoms? Eth. Last. C double bond O is amide group. Ethanamide. Ethanamide. I should write ethanamide. Okay, got it? Chala. So this is your molecule. Easy, easy. Shall we solve one more question? One more question. This is in page number 390. Let's start. The IUPAC name of the following name of the compound having formula. Okay. So how should I number this? First of all, the amino group should get the minimum number. Correct? Now I can't start numbering here. It should get the minimum number. So I will take this. I'll take this 1. This is 2. This is 3. Okay. So how to name this? So it is 2 amino. Okay, 2 amino both are there. Then third position 3 hydroxy. How many carbons? Prop. Oh, superb. 2 amino 3 hydroxy propanoic acid. Correct na? The propamam, where is that oic acid? CO. See this one na? COOH. COOH. But now ma'am, acid group should get first one na? Acid group should get first. Hydroxy group should get second. Perfect. This is an acid group, so I should not number it from there. I have to number it in a different way because this is an acid and COOH is given first preference. This is your COOH. So 1, 2 and 3. So now name it 2 amino 3 hydroxy propanoic acid. Perfect? Yes? Correct? Perfect. Now next question. This is in page number 390 again. What is IUPAC name of the following compound? What is the name of this compound? Okay. So how should I name it? Let's see. 1, 2, 3, 4, 5 and 6. Okay. No. Now amino group should get minimum number. So I should not number it from there. I should go back again and number it from this side, because amino group there are no substituents, means I have to number it 2, 3, 4, 5 and 6. So what is this compound? This is first there is a substituent here, CH3, 5-methyl 3-amino hexane. No, 5-methyl 3-hexanamine. Correct. Yes, 5-methyl 3-hexanamine, because amine should come at the last. So 5-methyl 3-hexanamine. So option B is the correct one, because last option B, because amine everywhere you see. Amine we are getting at last. Amine we are getting at last. Amine is last. So amine should come, group should come at the last. So that's the thing. Easy? Easy. So one more. Let us see. Suppose if they ask you, there is an alcoholic group. Till now we didn't do alcohol. Na? If there is an alcoholic group like this with amine group, how should I name this? So parent chain is eth, functional group is all. So you should name it as 2-amino ethanol. Okay. The next one. Suppose I have a group in this way. You tell me what will be the name of this. There is a big group like this, there is a big group like this, and there is one group here. Okay, no problem, let it be anything. First of all, count the number of atoms. 4 1 2 3 4 5 6 7. Oh, the parent chain is heptane. 7 heptane, parent chain is heptane. Now it is, there is only one hydrogen, means it is compulsory at which position? This is 1, this is 2, this is 3, this is 4, this is 5. That should get minimum number, na? So 2. Which one? N. Then to N what is attached? Methyl. Correct? Amino heptane. Heptyl amino? No. Amino heptane. Chalo. Next one. Suppose if you have an amino group in this way, COH, one acid group. How should you name it? You have to start numbering it from the acid group. Correct, no? So that comes preference 4-amino. Students. It is 4-amino butyric acid. Correct, na? Because the functional group. Correct? Okay, further we will see. One more we'll see. One more. How many? 3 na? Fourth one. One more. Suppose you have your aniline group here and you have your bromine. So what do I name it? It is 4-bromoaniline. Easy. So I told you na, the students who are studying for the first time also, who are studying the last time also, one revision. So one more thing. There is one more molecule, N, CH3 C2H6. Now there is no hydrogen. So I am writing two different groups are there. So I'll pick up separately. First the larger group, N-ethyl. Then comes N-methyl aniline. Okay, you see. Sixth one. Now I have taken a ring. Then I said I have two alkyl groups here, same groups. What would I do now? No hydrogens, both are same. So N comma N, dimethyl benzamine. Dimethyl benzamine. Correct na? Yes. So you are understanding? Easy? Easy? Very easy. Simple. Now, till now, the nomenclature is complete. We tried with primary, we tried with secondary, we tried with tertiary, we have tried with examples. Quaternary is not required. So, only think maximum questions will come from this. And you should also know the order. When COH group is there, first preference should be given. Okay, done. Now, let's go and start with your preparations. Nomenclature, 1 mark question. Now, I'll give you the preparations. Chalo, careful with so many MCQs. All right, now let's come and start the next topic. Preparations, very important. Chal. Whenever you are studying preparations of amines, there are a lot of questions which are asked on name reactions. I'll do that. Let's see. So in preparations, as I said, nomenclature we did already, classification we did, structure we'll be doing. I am starting with the preparations now. So basically, whenever, as I said, in preparations, whenever you do one-page revisions are most important to your exams. Whether it is exam, whatever it is, what you do, take a printout. Okay, take a printout and please paste it on your study table. Take a printout and study table will be there. No, place that so that whenever you go brush your teeth, see that. You come drink water, see that, like that. Okay, chalo. So this is the one-page revision. This I made with great difficulty. Careful, use it. I love students. If I see students smiling face, I feel so happy. Yeah, I know. As a principal, I know your struggle, students. But anyways, let us start the preparations with the questions gradually. Whenever we are studying preparations of amines, I don't know why my markup and the size is bold. Okay. First, we have a preparations of amines. I can learn or prepare amines by a process called reduction process. Reduction of what? Reduction of nitro compounds is one type of preparation. Okay, reagents, everything we will learn. Then reduction of nitriles. Then reduction of amides. These three reductions. There is also one more reduction, but I call that as Hoffmann's. That is degradation. That is also reduction only. Not reduction, other degradation. One carbon less. Hoffmann's bromamide degradation reaction. And this is 1, 2, 3. This is 4. And the last one is ammonolysis. Ammonolysis of alkyl halide. Is it okay? Okay, done. Easy, very easy. So understand carefully and we will be doing questions. See this. First we will understand the topic, then we will solve the questions. Clear? Chalo. Let's understand the topic carefully first. What did I say? I am going to do the preparation by which process? Reduction. Correct na? Careful, very careful. Whenever you see a reaction, if you should understand that is reduction reaction means you should see first reducing agents. You should see the reducing agents. What are the reducing agents which we are going to use? Careful. Whenever you are converting RNO2 nitro groups to your RNH2, I can use reducing agents like nickel. I can use reducing agents like platinum. I can use reducing agents like palladium. I can use metals like Sn by HCl. I can use Fe by HCl. I can use zinc. I can use zinc also, but concentrated HCl. Yes, all these are concentrated HCl. Concentrated. So active metals also you can use for reduction. So when you see this, that means you are doing reduction. What is reduction? Basically, removing of oxygen and addition of hydrogen. You are removing 2, you are adding 2 hydrogens. Simple. That is aliphatic or aromatic. First thing. I am taking RNO2, I am taking ARNO2, both aliphatic and aromatic. I am adding all the reagents. I am adding nickel, platinum or palladium or the different types. One I am adding. So, as I said, careful, removing of oxygen, addition of hydrogen. So, if I am taking 3 hydrogens, I am adding, suppose 3 hydrogens. What will happen? RNH2, it is prepared. ARNH2 prepared. What happened to 2 more hydrogens? Those will come out with oxygen as water. That's all. Easy. One more we will see with SnHCl. Again RNO2 plus ARNO2. I am adding reagents like Sn or HCl or Fe or HCl, anything you can take. Same story, I'm adding 3 hydrogens, I'm adding 3 hydrogens. What will happen? 2, this gone, this gone. RNH2 is 1, ARNH2 is 1. And what will I get? 2 water molecules, 2 water molecules. That's all. This is only reduction of nitro compound. Simple, very simple, damn easy. Now, using this concept, let us solve a question. Okay? In the exams, such questions are quite common. What did they give me? Nitro compound. What did they give me? 10HCl, which is a reducing agent. So what will happen? First thing, oxygen out, hydrogen in, and A molecule is NH2. Correct na? This one. Now we didn't study till now NaNO2 plus HCl. Oh no, I'll do that. So NaNO2 plus HCl, this reagent converts aniline into BDC. This is A molecule. BDC, I will do this, but as of now, because the question is there, I am doing it here. BDC. Next, water molecule, what is it doing? It is doing hydrolysis. Hydrolysis. So nitrogen gas out, OH group in. This is doing hydrolysis, means it is adding the OH group. So it gets converted to phenol, OH. Nitrogen gas is out and your HCl is out. In water molecule, H and OH, na, one OH is added, hydrogen comes out with Cl. So this is molecule C. Easy question. Same thing. See this. They're asking convert nitrobenzene to aniline. Okay. I'm taking nitrobenzene, NO2. You have to convert it to aniline. You have to convert it to aniline. Correct na? You tell me. What was that extra? Simple. Oxygen in, oxygen out, hydrogen in. Take one, SN by HCl. Simple. Because there are 6 carbon, 6 hydrogens. Na? So I'm going to add 6H here. Because what happens? 6 are there. I need to remove that. So 6 water molecules are out. Okay, students, easy. So 2 are in with 2 oxygens. 1 oxygen or 2 oxygen atoms go and 2 hydrogen comes in. So this is your nitrobenzene and this is your aniline. Easy. First question easy. Okay, very easy. Such questions they will ask you. Now we are going to see the next variety of preparation, that is the second one after reduction of that reduction. Ma'am, shall we do the reduction of amines? No, we will do step by step. Now I'm going to teach you Hoffmann's method. Careful. This is Hoffmann's method, not Hoffmann's bromamide or degradation. Hoffmann's method, or also called as ammonolysis of alkyl halide. Ammonolysis of alkyl. Understand carefully, students, for alkyl halides. So what happens is, your alkyl halide, that is your RX. Okay. So alkyl halides, when they put it in ammonia sealed tube, okay, when this, what do they do? They take alkyl halide. Okay, they take alkyl halide, they add it alcoholic solution, and in that alcohol, along with alcohol, ammonia will be there. Everything will be sealed at 373 Kelvin. When they seal all this alkyl halide, ammonia, alcoholic ethanolic solution at 373, it will form a mixture of 1 degree, 2 degree, 3 degree and 4 degree amines. Okay, so this is basically ammonolysis. You are adding your alkyl group to this. What is that? We'll see. See, what will I do? I said na, I'm going to take alkyl halide RX. First, what will I do? I'm going to add with the ethanoic solution of ammonia. It's nothing but there is an amine. I'm taking one amine. This is 1 degree. Then what will happen? Slowly your HX comes out, means one hydrogen comes out with X, and R goes and adds. Every time R count will be increasing. R2, R3, R4. Now what is decreasing? One hydrogen is decreasing. Again RX. One hydrogen is decreasing. Again RX. One more hydrogen is decreasing. Then it becomes a salt. This is secondary, this is tertiary, this is quaternary. This is ammonolysis. So this RX order, careful, this is important, order of reactivity, and what order they react. Order of reactivity of halides. Order of reactivity of halides. What is that order of reactivity? Ri greater than Rbr greater than RCl. Okay, my why? Reason. What is the reason why Ri is first? Remember, halogen size is larger. Larger the size of halogen atom, larger the size of halogen atom, what will happen? Easier to cleave Rx bond, break or cleave Rx bond. Correct na? Larger means more bond length I can easily break. Yes, this is your ammonolysis. Now, what is important further is, what is the limitation of, they'll ask you as one more question. What is the limitation for your Hoffmann's method? What is the limitation? Why we are not using frequently? What is the limitation? In Hoffmann's method, it gives mixture of amines are formed. Mixture of amines are formed. Correct now? Because if you want pure product, all mixture of amines, and mixture of amines are formed, and it is difficult to separate. That's why Hoffmann's method, we are not difficult to separate. Is it okay? Okay. Now, method to get only one product by Hoffmann method. What should I do? I want only one product. Only one product I want by Hoffmann method. How should I do this? Correct? Now, first thing, when primary amine, when 1 degree amine, primary 1 degree amine, if you want only 1 degree amine I want, then what will you do? Ammonia to be taken in excess. Ammonia to be taken in excess. Then first one you will get 1 degree amine excess, 1 degree. Second, suppose when you want quaternary, if somebody is asking you, you want a quaternary compound, before I go to this question, okay, you want quaternary ammonium salt you want. Somebody is asking, prepare quaternary, 4 degree quaternary amine. Then what should you do? Then you should take alkyl halide excess. Correct na? Because then R group, this alkyl halide, if you take only quaternary, I'll get alkyl halide to be taken in excess. It is understood. Correct na? Yes. So, this is the concept. Now, one more question they'll ask. Can you use Hoffmann's method to prepare aryl amines? Yes. They'll ask this. Simple answer you'll write. Method is not suitable. Question and answer. Question I told, answer I'm writing. This method, Hoffmann's method is not suitable for aryl amines as they are less reactive than alkyl halides towards NSR, nucleophilic substitution reactions. Correct now, because of their resonance. Correct. So simple. So simply I can replace. But in case of aromatic amines, what will happen? There is a benzene ring, there is an aromaticity, it shows resonance, all these concepts. Resonance, their resonance stabilized. Easy. So how many questions I gave? This is one question. This is one more concept. This is one more concept. Easy. Chalo. Now let us solve a question. They'll ask you like this. Write short note of ammonolysis. So how should you do? You have to start. Ammonolysis means don't simply write that line and come. You have to show step by step. First you take ammonia like this, ammonia. Then it forms RNH2 plus HX. Please draw step by step. Take the same RNH2, then add one more RX. What do I get? R2 NH plus HX. Take this again, keep adding 1 to that. Keep adding 1 to that. Then this becomes R3 and then N and HX. Then again take that R3 tertiary and then add RX. So this becomes R4 N plus and quaternary salt. That's all. So this is how you should write. Okay, step by step. Right, students? Easy? Easy. Now, after your ammonolysis, now we are going to study the third type, that is by reduction of nitriles. Careful, nitriles. NO2 is over. Ammonolysis is over. Now we're doing reduction of nitriles. So in nitriles, as I said, what are our nitriles? R, C, triple bond N. This is your nitrile group. Okay. Whenever you're reducing means nothing. Reduction means addition of hydrogen. Nitriles, whenever you're trying to convert it to CH2NH2. How did I get this? First of all, you should remember what reagents you're using. Careful. Earlier I said active metals you're using. Okay, so SnHCl, FeHCl, like that. Nickel, platinum, palladium. Here, the reagents or the reducing agents which we'll use is hydrogen, addition of hydrogen in the presence of nickel, sodium amalgam in the presence of ethanol. These are all used for conversion of nitriles. Yes, lithium aluminium hydride and hydrolysis. All this you can use all this. Got it, students? Easy? Yes. Now check. What will I do? I will take R nitrile. Simple, nothing you should do. Write the reagent. Reduction means addition of hydrogen, na? Correct, no? Break. Assume you're breaking the bond. Careful. And here hydrogen and here hydrogen you're adding. Okay. What you're doing? Break this bond. CH2 NH2. That's all. R CH2 NH2. Same thing if I'm taking amides. These are called amides. Amides. Reduction by amides also. Fourth one also amides also we'll do here only. Same lithium aluminium hydride by water. What will you do? Careful. Remove this oxygen, add hydrogen. That's all. Add hydrogen. R C H2 NH2. Amide to amine. Nitrile to amine. Amide to amine. Nitrile to amine. Easy. Simple, easy. Nothing. There's no logic. Simple question. Same thing. After I understand, if they give you this question. See this. What is this? This is amide. What is this reagent? Reducing agent. Amide will get converted to, remove this, send one hydrogen inside. Amide will get converted to amine. Primary amine, 1 degree amine. 1 degree amine. Easy? Very easy. Question is easy, concept is easy. That's all. Chalo. Next, after this, we are going to do, till now what did we do? We did reduction of your first concept RNO2 we did. Then we did reduction of nitrile. Then we did reduction of CONH2. Then we did ammonolysis. Correct na? Monolysis. Now let us do one more preparation that is important. Gabriel. How many did we do? 1, 2, 3, 4. Na? Fifth one I am writing. Gabriel thalamide synthesis. Okay, now what is this? So basically Gabriel thalamide synthesis is used to prepare 1 degree amines, primary amines. Means there are 2 hydrogen atoms in one alkyl group. Here what are important? Careful. First requirement is I require thalamide. Second, I require potassium hydroxide. Third, I require alkyl halide. Fourth one I require is alkaline hydrolysis, means sodium hydroxide aqueous. Alkaline hydrolysis will happen. Alright, step number 1. I am taking thalamide. Thalamide is 1 ring. Then imide 1 hydrogen. This is thalamide. First step 1, I am introducing potassium hydroxide. The bond breaks here, and potassium goes and attacks. So the same thing, you are going to get one N plus K minus. Hello? Got it? Sorry, N minus K plus. N minus K plus. What is this? This is potassium thalamide. This is thalamide, students, potassium thalamide. Now I'm introducing third one, that is RX, whichever group you want to, ethyl, whichever you're going to use. So what will happen? This R goes and replaces the potassium. Okay, then I will get NR, alkyl group. Now I'm going to do, careful, the last one. I'm going to take that alkyl group in a potassium salt, further heat it, and then I'll do alkaline hydrolysis. Alkaline hydrolysis, it's nothing but base dissolved in water, that is sodium hydroxide aqueous. Then what happens? The bond breaks here and that sodium hydroxide COONA plus your 1 degree amine, which is the main product, is formed. 1 degree amine, which is the main product, is formed. Easy. So aromatic prime, first thing, easy. First question is, I need these reagents. I get primary amine. But remember, aromatic amines cannot be prepared by this method. Why? Why? If the question is asked, remember, before we go to this, aromatic amines are not prepared because aryl halides, this is alkyl halide, na? Here I'm talking about this. Aryl halides do not undergo nucleophilic substitution with potassium thalamide. Remember, once again, why aromatic amines are not prepared like primary amine means, this here when you take RX, that's okay, easy. But when you take ARX, aryl halides do not undergo nucleophilic substitution with potassium thalamide. Write that. I don't have place, I'm not writing it. Okay, right? Easy? Easy. Now, how is this question asked? See this. How do you synthesize ethanamine with Gabriel thalamide? They're asking. Ethanamine. They want me to synthesize ethanamine. C2H5NH2. Nothing. Same concept you take. You're going to take, again I'm writing the same thing. I'm taking thalamide, NH. What will I introduce first? KOH. What will I get? I'll be getting potassium thalamide. Correct na? Same thing. NK. Now I want this product, means here instead of RX, here what did I do? I did RX na. Here you'll introduce C2H5Cl. Then what happens? This molecule, this is potassium na, NK. This molecule will combine and it forms NC2H5. That KCl is out, NC2H5. Okay. Now what will I do? I will do base hydrolysis, aqueous alkaline hydrolysis. Then you get, this bond is broken. You get 1 degree ethanamine, what they asked. You will write it as ethanamine. And then you will draw the remaining phthalic acid. The last one is your phthalic acid. You can write here. Because I added H plus, I finished with phthalic acid. Here I added sodium, I have finished with this. So, phthalic acid molecule. That's all. So, this is what I did. So, name everything please. Thalamide. Like this. Everything try to name. Okay. Done. Next question. Next question. Next question or next name reaction is very important and easy. The last one, sixth one is Hoffmann bromide degradation reaction. Okay, Hoffmann bromide degradation reaction. I have a lot of questions for this. I'll tell you. So basically, Hoffmann's bromide degradation concept number 1 is, careful, concept number 1 is you are going to get compounds or you are going to get product with 1 carbon less atom. Simple. In Hoffmann's bromide, basically I will get or I will take amide which will be converted to amine with one carbon less. Here how many carbons are there? One carbon. Here how many carbons are there? No carbons. If I take 4 carbon atoms here, carbon, I will get only 3 carbon atom amine. 3 carbon atom amine. 1 carbon less product. Clear? Yes. But for this Hoffmann bromamide reaction, I am going to take bromine. I am going to treat it with a base. NaOH or KOH also okay. So what will happen? This bromine and sodium hydroxide will help in the degradation, removing this oxygen and preparing NH2, primary amine, 1 degree amine. Okay, 1 carbon less atom, basically 1 carbon less. What is the left out one? The left out one is your sodium carbonate, sodium carbonate, that CO3 comes out, and your NaBr, I have less place because I wrote in the other way, and water molecule. I went and wrote there. Na? So balance it. This is 4. This is your 2. That's all. And this is your 2. Okay, got it? I wrote it another way. So basically, what is my understanding? In Hoffmann's bromamide degradation, 1 carbon less atom I get. I'm sorry, I went and wrote that side. Okay. So using this, we will solve certain questions. Hope you understand this. Easy. 1 amide getting converted to amine. 1 carbon less. The byproducts are sodium carbonate, sodium bromide and water. Okay. Let us understand this question. An amide A reacts with bromine in aqueous solution, aqueous sodium hydroxide, and forms amine containing 3 carbon atoms. Identify the compound. See this, they gave a clue. 3 carbon atoms I want. That means I should take 4 carbon atoms now. Correct? First of all, what is this reaction? This reaction is Hoffmann bromamide degradation. Hoffmann bromamide okay. Hoffmann's bromamide degradation. This is correct na? Degradation. I saw the reagent and I said okay. I also know 1 carbon less compound, 1 carbon less product I get. 1 carbon less. Okay, product. Now from here only I can predict. They said this is really bothering. They said 3 carbon atoms means, careful, I know it is amine. If I have to get 3 carbon atoms means here in the product I should take 4 carbon atom amide. 4 carbon atom amide. Correct na? Amide to amine only na? 3 carbon atom amine. That's all? Yes? Sure. Let's start the reaction. Let us see which is correct. Now ma'am, they said 3 na? So I can take this also, no? I can directly mark here, no? Butanamide. They didn't specify anything. They didn't specify straight chain, branched chain, nothing. If it is product 4 means I can directly tick and come out. Careful students here. Maximum students go wrong. Let us see. So basically, I'm going to take an amide which is 4 carbon. There are 2 options. First option, 1, 2, 3, 4, and this is one option. Then there is one more option like this. This is both are 4 carbons. Now same story, I will add bromine. Here also I will add bromine. Same story, I am adding sodium hydroxide. Here also I am adding sodium hydroxide. Correct? Now you only tell me 1 carbon less. 1, 2, 3, 4. So I will get 1 carbon less propanamine. Along with this your sodium carbonate, along with this sodium bromide, along with this water are same. In this case, same story. CH3, 1, 2, 3, 4 are there. You will get now, you will get 2, only 3. Same story, Na2CO3, NaBr and water. Correct na? Yes. So what is this? This is 2-methyl propanamine. Correct no? This is 2-methyl 2-methyl propanamine, 3 carbon atoms, and this is propanamine. But now both the products, I didn't balance students. I did in the earlier reaction, I balanced already. Correct na? Now go back and check the options. They said 2-methyl, no, here it is 2-methyl, sorry, it is 2-methyl propanamide. This is 2-methyl propanamide. This is butanamide. Now ma'am, both options are there. Which one should I take? Which options? See students, normally such questions, even if you mark it A, it is right. Even if you mark it C also, it is right. Nobody, they'll give you mark. It's okay. Because both are correct. Because they didn't mention which is straight chain, which is branched. So I'm giving both confirmations. You see? Easy. So next question. Careful. This is reaction 1. This is reaction 2. I didn't balance it. Already I did it in the previous question. Let us see this question. A compound having molecular formula C3H7ON reacts with bromine in the presence of sodium hydroxide to give compound B. The compound reacts with nitrous acid to form alcohol and nitrogen gas. Identify A and B and write the reactions. Oh, easy. So do I have place? I don't have place. I have to do here only. Okay. Now see here. First of all, what is this type of reaction? The type of reaction is Hoffmann bromamide degradation. Correct na? Because bromine in sodium hydroxide, aqueous. So Hoffmann bromamide degradation reaction. Write full form, degradation reaction. Now what did they say? C3H7ON. Did they give any this one? How many carbons? Yes, they gave C3 carbon. That means I should get C3 in the reactant, means I have to get C2 in the product. Correct na? Chalo. Let us take one amide. Hoffmann's bromamide means it is an amide group. Kana? Amide C3. This is C3 and H2. This is A. Then I'm treating with this bromine and sodium hydroxide. I get 1 carbon less, amine. This is B. They said then HONO, HNO2. So basically students, HONO or HNO2, what is this? HNO2 or HONO basically is used for doing hydrolysis reaction, diazotization as well as hydrolysis. Both the things will happen. So whenever you are adding ethylamine HONO, remember it will do 2 things. One is diazotization, forming BDC, unstable witches, and it will also do hydrolysis reaction. Hydrolysis means it adds water, or it adds water and removes the nitrogen and hydrogen gases. So ethylamine is getting converted to ethanol, hydrolysis and diazotization, along with nitrogen gas and hydrogen gas. You see? So the diazotized salt, whatever you're getting, slowly it degrades and it comes out as nitrogen gas. It decomposes nitrogen gas. So here ethanol is a major product. Ethanol. So here what they didn't, this is not B basically. They said B reacts with HONO, so I should not write B. Ethanol is B. I should rub this as B. Now after you do such questions, you're going to write it down. A is CH3, CH2, CO and H2. B is CH3, CH2 and OH. Name it. This is propanamide. This is ethanol. That's all. You see? Easy. Next question. See this. Which of the following reactions is appropriate for converting acetamide to methanamine? They said. Nothing, no reagents, nothing they gave. Correct? Nothing they gave. So before I do this, careful. Did they give anything? Only name reactions, which is reacting, which is correct, they're asking. Okay, first thing, let us see. Hoffmann bromamide reaction. Acetamide to methanamine, amide to amine. Okay. Amide to amine. What is that reaction? Amide to amine is Hoffmann's bromamide only, na? Directly I can mark it. They didn't ask you any reaction, just they asked you to mark. Easy? Easy. So what will I get? Acetamide. Acetamide, if it reacts with bromine, sodium hydroxide, just for your revision students, it forms 1 carbonless amine plus KBr. Here if I take sodium hydroxide, NaBr plus Na2CO3 plus water. I am not balancing it, just for your understanding. Next question. Let's see this question. Oh, method by which aniline cannot be prepared. Oh, they're asking aromatic amine from which method I can not prepare aniline. Careful. As soon as you see, ma'am, what is this? How? Please write the reactions in each case. It is easy for you to understand. Write the reactions. I have place, next place. No, I don't have place. I'll do it. Hydrolysis of phenyl isocyanide with acidic solution. Okay. Let us write the reaction. Very small alphabets I'll write. Hydrolysis of phenyl isocyanide. I am doing hydrolysis in acidic medium. So isocyanide will get converted to aniline and you get formic acid. And you get formic acid. I am balancing 2 here. Okay, I got aniline. Yes, I got. So then which cannot be, they said this is giving us degradation of benzamide. I am taking benzamide. Degradation bromine, NaOH. My students, there is no place, that's why I am not balancing it. So what do I get? 1 carbon less aniline plus your sodium bromide, sodium carbonate, Na2CO3, and your water molecule is already there. So here also I am getting aniline. This also is giving. Reduction of nitrobenzene. Reduction of nitrobenzene. I said now you can use platinum, palladium, anything in the ethanol, rather ethanol with palladium. So hydrogen, take out C6H5 NH2, and if I take 3 here, 1 has come here, I'll get 2 water molecules. This also is giving me aniline. Last, potassium salt of thalamide. Oh, this is nothing but Gabriel thalamide synthesis. Gabriel thalamide synthesis, what does it give, students? Thalamide reacts with RX and KOH. If you do hydrolysis with sodium hydroxide, what do you get? You get only aliphatic amines, or primary amines. Correct, na? So these are all aryl amines. This is aliphatic amine. So aniline is an aryl amine. So Gabriel thalamide synthesis, this does not give aniline. It only gives primary amine, not aromatic amine. You see? So I didn't cross it. I am saying which one will not give. Please don't consider this. So option is, I will erase all here so that you not. So the correct option is Gabriel thalamide synthesis does not give aniline. It gives amine. See? Next question. Okay, same story, same thing. They give you in different ways. So how many carbons? 3 carbons. What will you get? You will get only 1 carbon less. Correctness, students? Sorry, 1 carbon less. Methylamine. You have to name it, students. Methanamine. If you don't name it, you lose mark. Along with this, you'll get Na2CO3. So many times I'm writing the same reaction, but for you to understand it. Water molecule is always 2 in this case. NaBr also is 2 in this case. Okay, chalo, done. Next question. Physical properties. So I did preparations. Now we'll do the physical properties. All the questions are clear, I believe. Alright. So basically, in physical properties, simple concept. I'll explain what it is. Remember what to do. In physical properties, first thing, amines. I'm talking about lower amines. Lower amines means the amines which are like primary amine in that way. Lower amines, it is like this. Lower amines, it forms hydrogen bond with water. This also forms hydrogen bond with water. This also forms hydrogen bond with. Correct, na? So lower amines are soluble in water due to what? Due to H bonding or hydrogen bonding. Correct na? Now, if I talk about R2NH, if I talk about R3N, now tell me, this is more soluble than this because there are bulky R groups. This is more soluble than this, there is bulky R groups. Only one hydrogen bonding can form. Here in the last case there is no hydrogen bonding, no H bonding. Correct na? Yes. So what is the concept? What is the concept? Concept here is, in physical property, as R group increases and H group decreases, solubility decreases because hydrogen bonding is less na? Correct. Now tell me about aniline, aromatic amines. Aniline and all these aromatic amines, are they soluble in water? Yes. Aniline is insoluble in water, basically, if I have to tell you. Why? Because there is a bulkier aryl group. There is a large aryl group here. Correct? That's why it is insoluble in water. Insoluble in water. Okay. Now, next concept. Next concept, this is clear? Easy? Very easy? Any doubt? Sure. Now, next if they ask you, the intermolecular association, if I take primary 1 degree, 2 degree and 3 degree, hydrogen bonding, the extent of hydrogen bonding is more on 1 degree, less in 3 degree because there are no this one. So if the question is asked, why 3 degree amines are less soluble in water, means absence of hydrogen bonding. Why 1 degree is more soluble in water? Presence of hydrogen bonding. Suppose if they ask you a question, if they ask you to write the order of solubility, okay, they ask you a question, order of solubility. Now I have this one, CH3, CH2, CH2, NH2, 1, N, CH3, CH3, CH3. This is A, this is B, there is one more, CH3, CH2, NH2, C. Now tell me, among all this, which will have more solubility? Yes, C, because alkyl groups are less and 2 hydrogen atoms. Then which will be more soluble? Which will be more soluble? Yes, B part. Last, see A part, because there are 2 hydrogen atoms and okay, bulkier but better. Then last, B will have minimum. Why? Because there are no hydrogen atoms and no H bonding at all. Hence insoluble in water. Easy? Means H bonding is required, then only. Understood the concept? Now let us solve a question. Arrange the following compounds in increasing order of solubility in water. You only tell me, just now I said you should check for the hydrogen atom. So let us take this as A, this is B, this is C. Sabse zyada. Increasing order means the one which is more soluble. Here also 2 hydrogens, here also 2 hydrogens. Which one should I select? The smaller alkyl group. This is big group, na? This is smaller group. So C will be maximum. Then compared to this and this is a bigger group. A less than B less than C. Easy? Yes. In this case, what happened here? Careful, hydrophobic end is there. Bigger group. That's why it is taken सबसे कम. Okay, easy. चलो, next question. Account for the following. Primary amines have higher boiling point than tertiary amines. Same story, same concept. What should you write? Write like this. RNH2 have 2 hydrogen atoms which undergoes, write answer like this, which undergoes intermolecular hydrogen bonding. Correct na? Yes. In R3N no hydrogens and no H bonding. Hence, primary amines boil at higher temperatures than tertiary amines. Correct, ma? Because the hydrogen bond is stronger. I have to boil it. Correct? So, this is your boiling point question. Boil at high temperatures. Next question. Arrange the following in the increasing order of their boiling point. Now, you have amines, you have alcohols, you have tertiary. Now, here alcohol have more boiling point. Increasing order means the one which is highest. Let us C2H5 highest. Okay. Oxygen and nitrogen. Then compared to this and this, सबसे कम. This doesn't have hydrogen at all. Then C2H5NH2. Easy? Easy. The concept is clear, students. If the concept is clear, it doesn't even take 30 seconds to name it. Okay. Next, out of CH3 and NH3, which will have highest boiling point? You only tell me. Question number 1. This is A and this is B. CH3 NH3, which will have same concept. CH3 NH3 has 2 hydrogen atoms, hydrogen 1, hydrogen 2. So 2 H bonds. Even nitrogen also forms 2 hydrogen bonds, and this also hydrogen bonding rather. This also has. So CH3, 3 and no hydrogen bonding. So this requires higher, more temperature to boil. More temperature to boil. Same concept, correct na? Hence BP is high. Next question. Ethylamine is soluble in water, whereas aniline, same concept. Same, just write it in solubility. Ethylamine has hydrogen bonding. Aromatic arylamine or aniline doesn't have hydrogen bonding, hence it is less soluble in water. Correct? Now, next question. Nitro compounds have higher boiling point than hydrocarbons. Okay. Nitro compounds, same concept. Can you write in the same thing? Yes, nitro compounds have higher boiling point than hydrocarbons, having almost the same molecular mass. Here, in nitro compounds, you have, see this. Let us take this RNO2. Let us take this. One alkyl group I'll take here. Okay. Like 2 alkyl groups I'll take for you to understand. CH2, CH3. Okay. CH3, CH2, CH2. 3. Okay. I'll take the 2 alkyl groups. Okay. 2 alkyl groups. Now you only observe. Compared to this has more boiling point. Reason? This forms hydrogen bonding through nitrogen through oxygen. Correct na? But here no hydrogen bonding, hence boiling point is low or less. It forms hydrogen bonding with nitrogen, bonds with oxygen, hence BP is more. Is it okay? Done? Chalo. Next question. Nitro, okay, this is repeated, students. This is repeated. Sorry. That's all? Yes. So, these are your questionnaires on your physical properties. So, basically, physical property, they will ask you questions based on solubility, questions based on boiling point. That's all. So, students, till now, we did nomenclature. Now the actual concept starts. Nomenclature, we did classification, we also did preparations, we did physical properties. Now I'll be doing chemical properties. That is the biggest concept in this. Chemical properties, before that I'll be doing basicity, students. Concept of basicity I'll be doing in my next video. Thank you so much for watching. Yeah. Alright, now let's come and start the topic, that is basicity of amines. This is a very, very important topic. Why it is very important? Because here concept is simple, but they're going to give you questions. A compulsory question will come from this topic, which will ask you to compare the basic strength between different molecules. students. So this comparison means you have to know the concept first. So please concentrate on the concept. I'll explain you the concept, then we'll go and solve the different questions what are related to this. Okay, chalo. First of all, before we go to the basicity concept, we very well know we did the nomenclature, classification, structure is pending, preparations, physical properties. Now I'm doing basicity concept and questionnaire. Then I'll do the chemical properties of this. Okay, chalo. Then identification of the primary, secondary and tertiary also I'll do it. So before we go to this basicity concept, I should know what actually is basicity. Correct, na students? What actually is basicity? What does it mean? Simple question or simple topic. So if I say in chemistry, basically basicity of any particular element, I can talk in terms of it is a measure, means a measure of magnitude. So for which basicity means something. Basicity means something which can accept protons. Remember this, it can accept protons in the same way, or if you are accepting protons means you are donating electrons. Correct, na? Donate electrons. This is one concept. At the same time, you can also say that the number of hydrogen atoms replaceable, number of hydrogen atoms replaceable by a base, in an acid. So this particular statement, the last one whatever you're seeing, this one we use it normally when we use the base concept. Now I'll be using this concept. I'll be talking in terms of donation of electrons. Shall let us start the concept. Yes, now we are going to talk about a topic that is basic character of amines. I request all of you to concentrate and understand the concept. If you understand the concept only, you will be able to do the questionnaire. Careful students. Now when I take amines, amine is your RNH2. Correct na? This amines have a lone pair of electrons on nitrogen. Accepted? 1 2 3 4 5 6 7 8. So this lone pair of electrons, whatever is there, there's a bond here, there is a bond between hydrogen and everything. Because of this lone pair of electrons on nitrogen, your amine, lone pair of electrons on nitrogen, your amines will act as, or basically amines are basic in nature. This is the first concept. So because of this lone pair, they can donate it. Because they can donate it, they are basic in nature. This is accepted. This concept is clear. Okay, clear. Now how can I say that they are donating? Simple. Let us see. When I have amine, so amines are going to react with my acids. Amines are going to react with my bases. By doing what? By donating a pair of electrons. How? Suppose if I take this RNH2, lone pair of electrons, it is combining with an acid. X can be Cl, X can be Br, so hydrochloric acid rather. So this is a reversible reaction. So this nitrogen donates a pair of electron to this hydrogen and it's going to form RNH3 plus because it is donated and X minus. So this is trying to donate a pair of electrons, means something which donates pair of electrons. I said it is basic in nature, right? Or it is the basicity. Concept is basicity. So accepted. It's donating electrons to an acid. It's forming a salt. Same thing if I take aniline in this case. Same aniline, again lone pair of electrons. Same aniline is reacting with HCl. It's going to form a salt. Correct na? Now observe carefully. This is your anilinium chloride. Now what is this? This is acid. This is base. This is salt. Correct na? So accepted. So aniline is, or amines are basic in nature. Next, what happens when it reacts with a base? Let us see. Same RNH3 plus, a salt, is combining with a base. A salt is combining with a base. Let us take in this way. Gives me RNH2 donation plus your water plus X minus. So now observe carefully. Here it is reacting with a base and it is forming. In this case, careful with the concept. You are talking about the conjugate bases. So in this case, your this is acting as a base. This is acting as a acid. Got it, students? Conjugate acid, conjugate base, which is giving out water molecule. That means amines are going to have the basic property because of the presence of lone pair of electrons on them. Clear? Now this basic concept, what does it depend? What factors does it depend? So basically your amines are depending upon the basicity on which the factors on which basicity depends upon is, there are 7 factors, very important. Factor number 1, inductive effect. So any question which is asked on inductive effect, maximum questions will be asked on inductive effect, plus I effect, minus I effect. Yes, we also factors on which basicity depends is electron withdrawing nature. If you have electron withdrawing group, compulsory that will affect your basicity, like your Cn minus, your CHO, like your chlorine, like your NO2 groups. If they are there in the group, a particular molecule, it will affect the basicity. Third important thing, Kb value. If the Kb value means I'll be talking in terms of larger Kb value, I'll be talking in terms of smaller Kb value. Both the things I'll be talking about, smaller Kb value. The fourth factor on which your basicity depends upon is solvation effects. So any question may be asked on any topic, remember this. Next thing, it will talk or they will ask you in terms of steric hindrance. If steric hindrance is there in the molecule, what will happen to the basicity? Sixth point, I told 7 na? Relative stability of cation formed. Relative stability of cation formed. Cation formed means all these factors will be affecting your basicity. Seventh but not the least, availability of electrons and donation ability. So you will be talking basicity on all these terms. So whenever you are talking basicity, any one factor will be acting. But let us start and talk in terms of now donating electrons. So I am going to talk next concept after the factors. What are the factors which are affecting basic strength? Factors responsible for basic strength in aqueous medium. So there are two things, aqueous medium and gaseous phase, or aqueous phase or gaseous phase. Anything will work, both. Right. Now, first important thing, aqueous medium, remember, careful. Yes, order is ammonia is less than 1 degree amine, less than 3 degree amine, less than 2 degree amine. What is this, ma'am? What is this order? So in case of aqueous solution, when you are testing basicity in aqueous solution, there are combined effects which are acting. What did I say? Combined effects. All these combined effects are acting on this basicity. Like, as I said, go back, plus I effect is one thing which acts. Steric hindrance is one more factor which acts. Solvation of amines is one more factor which acts. The solvation is through your hydrogen bonding. So with all these factors in aqueous medium, if they give you a question, follow this order: 1, 3, 2 and 1, 3 and 2. Got it? Yes. Now concept number 1, next concept. Again I'm going one concept, I'll be going and understand it, please. Solvation effect and everything, one I'm going. Now aqueous solution is over. Now talk in terms of alkyl groups. Concept number 2 is I'm talking about alkyl groups. Understand? If the number of alkyl group or R groups increases, what will happen to the plus I effect? Plus I effect increases. That means, careful, and donation of lone pair of electron increases. Correct na? Because R groups are there, they are electron releasing groups. Yes, when electron releasing groups are there, more of electrons are donated. When more electrons are there, it will start giving out. That is basicity only na. See here, R3N, 3 alkyl groups have more basicity than R2N, more basicity than RNH2. This is okay. Done. Now next important thing, concept number 3. As alkyl groups are increasing, what will increase? Steric hindrance increases. Correct. When steric hindrance means bulky groups are increasing, what will happen? electron donating nature decreases. Electron, all these factors you should remember when we solve the question. Nature decreases because all are bulky. Correct? That means then what happens? RNH2 will be more basic than R2NH, then basic than Rn. Ma'am, you said this, then again you're saying yes. Careful, we'll be applying all this concept in the questions. Is it okay? Yes. Now, next concept, what we are understanding. Careful students, I'm going one after the other. Solvation concept. Fourth one. In solvation concept, that is when it is forming hydrogen bonding in the water molecule. Remember, as number of hydrogen atoms are increasing. Careful. Number of hydrogen atoms are increasing. That too stable amine. The order will be, basicity order will be RNH2 greater than R2NH greater than R3N. Done. Done. So careful, nothing. Only thing you should remember, size is indirectly related to your to solvation. Solvation is directly related to stability. Got it, students? I'm writing some important thing here. Size is indirectly related to solvation, and solvation is directly related to stability. Okay, got it? I am telling all the factors. Now I am going to take you into next concept, that is basicity, amine basicity in gaseous phase. Amine basicity in gaseous phase. All this concepts will be applying. You carefully understand. I'll be going with the questions, then you will understand. Aqueous phase is over. Now gaseous phase. 3 degree greater than 2 degree greater than 1 degree greater than ammonia. Yes. Yes. So here in gaseous phase, what you are taking? In gaseous phase, the first factor which acts is plus I effect. Plus I effect in gaseous phase. That's why 3 degree. Yes, basicity of amines rather is directly related to plus I effect. If plus I effect is more, means basicity is more. Basicity is more. Okay, is more. That means what is the order? R3N greater than R2NH greater than RNH2 and your NH3. This is in which phase? This is in your gaseous phase. Both are different, na? Both are different. Yes, suppose if they ask you a question like this, just understand carefully. Why is, simple question I'm asking. Why are alkyl amines more basic than ammonia? If they ask this question, how will you write? So simple, alkyl amines then ammonia. I am taking R3. Now see this, C N, your CH3, your CH3 and lone pair. Here how many are the alkyl? 3 plus I effect groups are 3 plus I effect groups are 3 plus I effect groups. More electrons are released. More basicity. Correct, na? Yes, more basicity. Then comes your 2 alkyl groups. Correct. Then comes your 1 alkyl group. Then comes your 1, that is your last NH3 group. NH3 group. Now here there are no plus I groups. Correct. Less electron density. Less basic. Correct, na? Yes, less basic. That's all. That is the reason. You have to write like this. Yeah, nice. Chalo. Next question we will understand the concept. Simple. They are asking you among the following, one more question they'll ask you, among the following, which is more basic? Which is more basic is what they are going to ask you. Okay. What question they have given? First, methylamine. This is A. Then ammonia. This is B. Then sorry. Done. Next, with cyano group D. Now tell me, among all this, which is more basic? Remember, concept is simple. If electron releasing groups are more, basicity is more. If electron withdrawing groups are more, basicity is less. This is clear, very clear. Now among all, which is electron releasing group? This one. Which is electron releasing group next? Hence compared to this and this, because this is okay. This is electron withdrawing, this is electron withdrawing. Compare these two. This is stronger electron withdrawing. This is lesser compared to that, lesser electron withdrawing. That means A is more basic than B is more basic than D is more basic than C. Correct na? So now ma'am, electron withdrawing groups are increasing means basicity decreases. Correct na? This is stronger electron withdrawing group means it is like it will try to drag the electron density and not give you. So if I have to tell you, it should be C and D. It should be C and D, correct? Because C is better compared to this. This will not give at all. So here I have to make it as, I have to make it as C and then D. Correct, no students? Because it will not give more electrons, but this will drag and it will not donate electrons only. Correct na? Chal. Next question. Next question. I am asking you, as I said, remember this. In aqueous solution, okay, in aqueous solution, you remember na, what was that? In aqueous solution, aqueous medium, aqueous solution or aqueous medium, solvation is directly related to or inversely related to size of ion. Ma'am, what is this? How can I remember? I'll make you a conclusion, you will understand. Okay, see here, basically for this is your 1 degree, correct na? This is forming OH bond. Here also it is forming hydrogen bond. Here also it is forming hydrogen bond. Greater R, N, R, H, H. Here it is forming hydrogen bonding. Here it is forming hydrogen bonding. Greater than that. R, 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 N, H, OH. Here it is forming 1. So here what happened? This is 1 degree, this is 2 degree, this is 3 degree. Now what is happening? In the case 1, smaller, this is in terms of aqueous medium please. Smaller size of ion, more solvation, correct na? More solvation and it can easily form. Here greater the size of ion, less solvation. Other way. Ma'am, how can I apply this? We will apply greater the size, less solvation. We will apply all these concepts in the, all this will apply. Okay, right? All clear, easy. Now, gradually we will go into, I'm going with factors, one after the other factors, and then only we can come to the conclusion. Next factor, which I'm going to take factor 3 or factor, I'm talking in terms of stability. Stability is indirectly proportional to charge. That means, careful, greater the stability of the substituted ammonium cation, stronger is the corresponding base. Once again, greater the stability of substituted ammonium cation. This is factor 3 students, please take it. I am writing factor 2 in this way. This is factor 1 in the, like, just take it. I'll tell you how, what to do. Okay, the substituted ammonium cation, stronger is the corresponding base. Stronger is the corresponding base. Ma'am, can you explain this? Obviously I'll explain. See this, 1, 2, 3. Okay, now this is 1 hydrogen, this is 1 hydrogen, this is 1 R group. Now tell me bottom molecule. Now it is a reversible reaction. Nitrogen is donating that pair to hydrogen and you get stable. Now see here, one more we will write. Here CH3, here N, CH3, CH3. Now water molecule. Now tell me, here again I am getting N, positive, H and Amines. Now greater, now see here, in this case it's the strong base. In this case, which is the strong base in both the things? Yeah, again according to the concept here, greater the stability. First of all, which is stable among these two? Which is stable? This is more stable. This is less stable. Now go back to the question. Greater the stability of the substituted ammonium cation, greater the stability of the substituted ammonium cation, stronger is the corresponding base, stronger base. Lesser the stability of the corresponding, because it is more bulky na, lesser the stability, the corresponding one is a poor base. The concept is clear, students? Once again, more the stability of the substituted ammonium cation, this is the cation, more stable is the base, lesser stable, poor base. Got it? This is factor number 3. Factor number 3. Okay. Careful. Now I'm going to go to factor number 4. Factor number 4. Steric hindrance. So much is there to study? Yes, you have to study, because any question can be asked in any way. Steric hindrance is inversely related to hydrogen bonding. Okay. See. Here okay, now you tell me which is more sterically hindered. This one. So more steric hindrance, less hydrogen bonding, less solvation. Am I right? Right. Same, only one alkyl group, so less steric hindrance, more hydrogen bonding, HB, more solvation. Ma'am, so much perfect. Now we have learned everything and we are going to combine everything now. Shall we combine everything? Yes. One more factor is also there for aromatic compounds, but as of now, learning all this, I am going to come to a conclusion. Yes, what is a conclusion? Simple, careful. What? In terms of combined effect, I am going to combine effects. I am going to combine 3 things. One is inductive effect, one is solvation effect, one is steric hindrance. So this is what you should remember for your exam. What is that? Basically, your CH3NH2 has what? Plus psi effect, because alkyl group is there. It has solvation effect also, correct? Here CH3 in secondary I am talking. Here also plus psi effect, here also solvation effect. In CH3, your N, your CH3 and CH3, in this case plus psi effect maximum, solvation effect minimum, because it has become bulky, correct? It has become bulky. So now what is the understanding? Careful. C2H5 I am combining all and writing NH is more than ammonia. Okay, right, in terms of your plus psi effect. Further going, ma'am, what are we writing? I didn't understand. Now I'm going to apply this further and I'll show it to you where I'm going to apply this. So quickly what we will do, we are going to just learn the aromatic amines basicity, and then go to the questions. As questions are here, we'll go to the questions. Okay, chalo, let us go to the first. We'll see in terms of basicity of aromatic amines. So aliphatic is over. I'll tell you how to apply basicity of aromatic amines. Now carefully understand. Basicity is indirectly related to number of resonating structures. Is it okay? Basicity is indirectly related to number of resonating structures. Done. Because more resonating structures means what will happen to the stability? More stability. Correct? Okay. So when it is more stability, electrons are less available. We don't have electrons to donate, na? When it is less available, what will happen to the basicity? Less basicity. Correct, na? Less basicity. Is it okay? Now they will ask you a question like this: compare between a basicity between aniline and anilinium ion. Okay, this is what they will ask. So anilinium ion, you know, right? This is your NH3 plus and resonance. Here between 1 and 2, here between 3 and 4, leave it 4 and 5, and this is your anilinium ion. So you know aniline. So basically aniline, when I say, I'm not drawing completely, just for you to understand. So here you have lone pair of electrons which is donated. Like that, when you show the rotating, when it rotates or resonates, how many resonating structures you'll get? In aniline you'll be getting 5 resonating structures. How many you'll get? 5 resonating structures. In anilinium you'll get only 2 resonating structures. Now you tell me, among aniline and anilinium, which is more? Just now I said more resonating structures means more stability. If it is more stable means it donates less electrons are donated. Because electrons are moving inside, donated. So less basicity. Correct, na? Less basicity. Is it clear? Better. So aniline is less basic compared to anilinium ion. Done. Okay, chalo. One more last question, last factor before I go. Okay, so chalo. Now important thing, remember this also for the question. Yeah, if electron releasing groups are there, basic nature or basicity increases. For example, like OCH3 group, your alkyl group, your C2H5, like that. If electron withdrawing groups are increasing, basicity decreases, like your NO2 group, SO3H group, like your COOH group, minus X group, like that. Is it okay? So careful, understand. This is done. Now we will go into the questions with all the concepts whichever I said, and this is a blank page. Let us not use it. And question. Okay, this is over. Now let us apply to the question. Carefully understand the questions. We will write. Among all this, which is the weakest base they're asking? What should I observe? This is all resonating structures. I said resonance means compulsory more stability. Correct? I am applying the concept. Can I use the next page before this? Resonance is observed here. How many resonating structures? You will have almost 5 resonating structures here. 5 resonating structures. Here no resonating structures because there is no aromatization. Here no resonating structures. Here 1 plus I group, it keeps donating electrons. Correct? Now tell me, among all, which is the weakest base? 5 resonating structures means option A. If I have to say, aniline has 5 resonating, this one means more stable. If it is more stable, it is the weakest base. Correct? In option B and C, no resonance at all. No resonance at all. So they will, to some extent they will donate electrons, but they are like to some extent no resonance. So alkyl groups means concept of alkyl group, whatever is there, at least to this extent this will donate, this will also, okay, no resonance only, there is no, clear, right? So because of this CH3 group. Now in D option, if I have to tell you, it is methylamine. It is methylamine, this one. So in case of alkyl amine, it donates electrons to NH2. So that's why this is the strongest base. They asked me which is the weakest base? So aniline, option A is the weakest base. Easy? Chalo. Next question. Among all this, they're asking you to find, arrange the following in increasing order of the basic strength. Okay, do I have place here? I don't have place. I will apply. Arrange the order. So I will just mark it in this way, students. First of all, I'll take here. All are benzene rings. Okay, right? All are benzene rings. Now what should I understand? If more of aryl rings are there, more of resonance. If more of resonance, less stability. Sorry, more of resonance, less donation of electrons, less basic. Correct? So here in this case, option A, C6H5, resonating structure, less basic. Compared to these two, this one, because there is no alkyl group. I mean, there is an alkyl group, but compared to this, the group, whatever is there, is directly attached to the benzene ring. That's why less basic. Among all, C6H5 is more basic. Increasing order, सबसे ज़्यादा, and the maximum one is this. Option B. Compare A, B and C. Tell me, among all this is electron withdrawing group, this is electron releasing group. So electron withdrawing group will not donate electrons at all, less basic. Then comes your aniline. It has resonance, less basic. Among everything, the happiest one is our electron releasing group. So this is more basic. Easy? Easy. So all the concepts what you are understanding, carefully applied. Next question. Arrange the following in increasing order of the basic strength. Now simple again. Same story. Now alcohol is given. Now tell me in the first case. Here NH2 resonance is there. In this case, to some extent, yes, I can indirectly attached. Okay, this is electron releasing group. Here it is in same question, almost similar, but option is changed. Second option is changed. Here it is directly attached to the ring. So what will happen? First one, C6H5 NH2, less basic. Then second one, this one. Third one is C6H5 CH2 NH2. Correct na? Reason is clear. This is electron releasing group. And B part, alcohol solvation effect is acting now here. Careful. Now alcohol, this is releasing group. In this case, both are releasing groups. Oh, nice. So C2H5 is less basic. Then CH3, CH2, NH2 is less basic than last one, which has two alkyl group. This will donate, this will donate. So this is more basic. Easy question? Easy question. Easy, na? Next. In the increasing order, hope you have noted the students. Yes. Arrange the following in increasing order of the basic strength. Okay. Similar question, na? Similar, repeated. Again, this is also repeated. A option, this is B option, this is C option. A will be less than, B will be less than C. That's all. Chalo. Next question. Arrange the following, because more and more questions we do will become more perfect. Right? Right. Arrange the following in increasing order of the basic strength. Here, aromatic ring aniline A less. Then compare your next one. This and this. This is B because it is attached directly to the ring. Then last one is C. Correct na? C2H5, C2, C6H5, CH2, NH2. Correct. Yes. Now this is what? Increasing order of the basic strength. Okay. So less basic, strong. Now observe. Arrange the increasing order of the basic strength. This also. Okay. This is A less than B less than C. Easy? Easy. Same question, students, repeated. Sorry. Same question is repeated, students. Sorry. Take it out. Take it out. Okay. Now let us see. I'm sorry. Repeated question. Same copy paste. Wrong. Next. Arrange the following in increasing order of their basic strength. Now here. Now see. This is least A. Then compared to this is B. Now this is two alkyl groups. Two plus I groups. Both are donating. Correct? That's why this is C. This is more basic. Correct? Chalo. Next question. Easy? Yeah. Why is methylamine more basic than aniline? Tell me the answer. Tell me. Yes. In methylamine, first, is there any resonance? No. In methylamine concept is first no resonance. Correct. Then alkyl group is plus I group. CH3 is plus I group. Correct. And that's why electron density on nitrogen is more. If it is more, automatically it donates electrons, hence more basic. Correct. Now it donates electron, more basic. When you talk about aniline, what will happen? Aniline, 5 resonating structures, less availability of electrons, less basic. Done. That's all. Now arrange the following again. Solution. There are 3 alkyl groups, 2 alkyl group, 1 alkyl group. So option A is less than option C, less than option B. Here plus I effect. That's all. You see? Next question. Next question. Which of the following is more basic than aniline? More basic than aniline. Okay. They've given different questions. Okay, they've given different questions. One is benzylamine, one is diphenylamine, one is triphenylamine, one is nitro. Let us first discuss carefully. All are aryl rings. All correct now. All are aromatic rings. So what is the concept first? Solution. Understand carefully. If electron withdrawing groups are increasing, basicity decreases. Among all this, NO2 group, CN group, SO3H groups, COOH groups, Cl groups, C6H5 groups, all these are electron withdrawing group. They will decrease the electron density on the ring because they will take it for inside for the resonance. Correct na? Alright. Among all this, what will happen? In this case, triphenylamine, nitroamine, diphenylamine, everything has double rings. All will show resonance. But in case of benzylamine, option A, what will happen? Yes, option A, benzylamine, comfortably the electrons are not localized in benzene ring, but this will donate electrons. That's why this is more basic. Okay, chalo. Next question. The correct order of basic strength of methyl substituted in aqueous solution. Careful, you know the order, right? Aqueous solution, you know the order. You remember the order? Yes. So in aqueous solution, what concept we will talk? Basically, in aqueous solution, careful, aqueous solution, always you will talk in terms of stability of ammonium cation. This is one. Or you will talk in terms of conjugate acid. Okay, by accepting proton from water. And that also it depends upon plus I effect. Correct na? So considering all this, option B is the correct answer. Okay, considering all this. So this is which one, students? They are talking all this into this one, two alkyl groups, single, and 3 but no hydrogen. So I am talking about in all terms of all. Okay. Chalo, next question. And any doubt? And one more thing is, if you have to further explain the question, if I have to further and make you understand, all whatever are there, if I talk about all this, all the conditions are favorable for secondary amines. Okay, you're talking about plus I effect of the group, you're talking about if you're talking about hydrogen bonding, and you're talking about basically steric factors, everything if you're talking about in aqueous solutions. So all these factors whatever are there are favorable for secondary amines. So secondary amines are strongest bases. or they are strongest bases. This is one concept. Okay, one concept. Yeah. Then if the alkyl group is small, there is no steric hindrance to hydrogen bond. It can easily go and form. So always, that's the reason what do we do in aqueous solution? Stability due to hydrogen bonding always predominates over. So what happens in aqueous solutions? In aqueous, whenever somebody is talking in aqueous solutions, because it is in water, hydrogen bonding concept, it dominates the concept of plus psi effect, and it dominates the this only will be talking, hydrogen bonding concept will be talking. So that's the reason we consider overall decreasing basic strength. That's the reason we say completely, they said which the correct order of basic strength of methyl substitute amine in aqueous solution. So I am considering all these and I am marking it. Okay, chalo. Next question. Arrange the following in the increasing order of the basic strength. Increasing order of the basic strength. Both questions same? Oh, again repeated? No, both are different questions. Alright. So arrange the following in increasing order. Now tell me same. Yeah, okay, this is almost similar, students. A is less than B is less than C. Here basic strength simple. A is less than B less than C. Correct na? Yes. Next question. Many questions. Among these two, which is more basic? This or this? Yes. Option methylamine is more basic. Why it is more basic? Presence of plus I group. Among this and this, which is more basic? This one, because of presence of plus I group. Among these two, which is more? CH3 and NH3, because this is resonating structures, less basic. Okay. Among these all, these like CH3 and NH2, alkyl group, 3 alkyl, tertiary and everything. So aqueous solution, simple. As I told you, careful. In case of small alkyl group, the order of basicity. So if small alkyl groups are given, order of basicity, or you can also remember the pKb value is not required, but simple. In aqueous solution, always secondary comes first, then 1 degree comes, then tertiary, due to solvation effect and plus I effect. Remember, in terms of aqueous solution, 2 degree, 1 degree, 3 degree, in terms of two concepts, one is solvation effect and one is plus I effect. Okay, yes, that's why in the last thing also, see this here, we have taken 2 degree, then we have taken 1 degree and then 3 degree. Correct na? Same thing. So here also same thing, 2 degree, 1 degree, and which one is this? First comes this C, I'll write here. Okay, this is first position, then comes your second position, then comes your third position. Okay, done? Yes. So this is first, this is second, this is third. Now last one, again this is also aqueous, same story. Which one comes first, students? First is secondary. This is first position. Okay, B greater than A greater than C greater than ammonia. Okay, D greater than ammonia, D. Okay, that's all. Easy. So in aqueous solution, try to remember this based on solvation effect and plus I effect. Clear? Chalo. Next question will let us see, which is the decreasing order of basicity of primary, secondary and tertiary ethyl amines and ammonia. Here they have given in terms of your plus I groups. Careful, yes. But did they mention anything they didn't mention anything about aqueous medium or this one, no? So normally whenever such question is given to you, when they say decreasing order of basicity, understand all the aliphatic, they have given all aliphatic, na? Yes, everything is aliphatic here. There is no aromatic. So all the aliphatic amines, careful, all aliphatic amines are stronger bases. Understood, na? Correct. This is because of plus I group. Correct. Yes. And that too in polar solvent. I am talking about in polar. Polar means in polar solvents means I am talking about aqueous solutions, aqueous medium. Basically I'm talking about aqueous solutions or aqueous medium. Then if it is aqueous medium, what is the order, students? 2 degree. I did here na 2, but this is solvation effect. This is solvation effect. But in polar solvent for aliphatic, this is the order. This is for polar solvents. Polar solvents. Okay. So what do I get? I get option D. This is 2 degree greater than 3 degree greater than 1 degree. Then ammonia. Okay. Next question. Arrange the following in the increasing order of the pKb values. Okay. pKb values is what they're asking. How do you judge the pKb values? Or simple. I'll just give you the order. Simple. Case 1. I'll write in the next point. So what did they give me? First one, they have given C2H5, C6NH, pKb. Okay. So the order would be C6H5NH2 greater than C6H5NH greater than C2H5NH2 greater than C2H5 taken twice NH. This is first one. Then increasing order of basic strength of next para, nitro, toluene, aniline. So B part, para, nitro, aniline. I am applying all the concepts which I said. Lesser than aniline, lesser than para, toluene. Then C6 aniline, this one, okay. Then the same B part first one, part second one. 6H5NH2 less than C6H5NHCH3 less C6H5CH2NH2. Done. Then C part, okay. One is aryl, one is alkyl. So CH3 taken twice, NH2 greater than CH3NH3, NH2 greater than 6H5NH2. D part, increasing of basic strength, gas phase. Okay, now they've given gas phase. So in gas phase always 3 degree, then 2 degree, then 1 degree, 3 to 1 and ammonia. 3 degree, 2 degree, 1 degree. Okay, in gas phase 3 degree greater than 2 degree greater than 1 degree greater than ammonia. Okay, so these are the factors. The first one, this is based on the pKb values. Second one, order of basic nature. Order, this is all border or this is also order. Here there is, they asked you increasing order. Here they asked you decreasing order. Here they asked you decreasing order. Is it okay? Easy? Easy. Chalo. Next question, we'll say this. The correct order of basic nature for the following compound is. Okay. Now you only tell me. Basically, okay, not required. Next page. But anyways, so tell me here. This is electron withdrawing. This is electron releasing. This is 5 resonating structures. So which one will be सबसे ज़्यादा? 3. So next, this is electron withdrawing. It will not give only. Correct na? Then this is 5 resonating, better than this. So option D is the correct one. Clear? Sure. Next one, this is blank page. Oh, not blank page, over. Oh, sorry. This is not a blank page, this is over. Okay, so all the basicity questions we have done. Correct na? All the basicity questions. So you're going to concentrate on basicity in gaseous phase. Careful order. You are going to call in aqueous phase, and you are going to talk in terms of your plusyl groups. You're talking in terms of your pKb values. Okay, okay, done. Now I'm going to teach you questions based on chemical reactions. Let's go and dive into the topic. Alright, now let's come and start with your chemical properties of amines. Till now we have completed everything, rather with the first part, nomenclature, physical properties, all basicity, nature, concept, and preparations and everything. Now let's start with the chemical properties. Careful. Maximum paragraph based question like identify A to B, B to C, on such type of questions will come from chemical properties. Chalo, let's start. So basically, before we start any chapter, normally I have the habit of doing one-page revisions. This is what is my habit. What happens with one-page revisions is, for you it is a complete understanding of the topic. So you can take a printout of this and paste it, and you can just see I have given preparation of aniline on this side and chemical properties or reactions on the other side. Everything with the reagent, with temperatures, everything. So all 2 to 3 pages are given in one particular thing. Got it? Alright. Like that, after preparations of aniline and chemical reactions, next is your reactions of aniline. Further, after this continuation, the reactions, what are there? Electrophilic reactions, all I have given along with oxidation and everything in one page. Easy? Easy. So let us start. Careful. Come back to the chemical reactions after one page revisions in detail. Concentrate, and we are going to do a lot of questions in this. Alright. First of all, in your chemical properties, first thing I have to tell you is amines. Basically, we have studied 1 degree, 2 degree and 3 degree, correct? So in your amines, 1 degree and 2 degree amines, they are going to undergo different varieties of chemical reactions like your acylation reactions. Addition of acyl chlorides, they'll be adding, or they'll be reacting acylation reactions. That acylation, what I'll be adding? I'll be adding acid chlorides. Okay. I'll be adding along with that acid anhydrides. This is the first reaction. I'll be adding esters. So all this acylation reaction, when they add, they are going to form a product called amides. So this is the first type of chemical reaction which we are going to do. That is nothing but acylation reaction. Carefully understand the concept and it will be easy for you. Acylation reaction. Okay. So for such reactions to perform, you require strong base. Alright. You require a strong base. So in the paper, when you see a strong base, something like pyridine. Okay. If you're seeing pyridine, and that pyridine is used to remove acid in this. And this pyridine will help to shift the equilibrium towards the right. It will shift equilibrium towards right. That means you will get product. So pyridine is trying to remove, the role of pyridine is to remove HCl which is formed and give me the products. This is okay. Chalo, let us start the first type of reaction. That is nothing but acylation reaction. First thing, careful. What is meant by acylation? So acylation reaction. Carefully understand. Again, while solving questions, it will be a problem. Your primary amine is there. Correct? So instead of this hydrogen, I'll try to open up the hydrogen. So acylation is the process of adding an acid chloride. RCOCl. So this is my acid chloride. And in which one? In the parent of a base, that is pyridine, a strong base. Then what happens? Your H and Cl comes out. And what is left out? You're getting a molecule. That is what? This is called substituted amide. What is this called? Substituted amide. Amide means NHCO group. NHCO group, substituted amide. This is your amide group. NH and CO, this group. You see, R, NH, COR. I just combined both by removing an acid, HCl. This is acylation. Simple addition of acyl group. Now let us see one more. I am going to take one more. Now I am going to add acid anhydride. I told you, we'll be adding acid chlorides, acid anhydrides, esters like that. Sure. I am going to add acid anhydride. Acid anhydride means acetic acid where you remove water. So acid anhydride formula is this, removing this. Then what will happen? Again I require a base for this. When I require a base, careful, the bond, whatever is there, it exactly breaks here and the bond breaks here. So this molecule and this molecule combines as an amide and the other one is an acid. What do I get? I'll be getting R NHCOR. So let me add it as R, one more R, so that you will know the difference. And what is the other one? RCOH, acid. So you will be getting an amide, substituted amide and an acid when you do ester. So when you add acid anhydride, this is what? Acid anhydride. I'm just breaking the bond and joining it. Third thing, if I am taking secondary amine, I am taking 2 R groups and 1 NH. I am adding RCOCl. What is going to happen in the presence of a base? What is removed? Your H and Cl is removed. HCl. And what do you get? You will be getting RNCOR. Correct? Now, same thing, somebody asks you, what will happen if you take tertiary amine? Tertiary amines, 3-degree amines will not respond or will not react or will not show acylation reactions because there is no hydrogen in them. No hydrogen. So tertiary amines will not show acylation because of the absence of hydrogen. Is this clear? Clear. Acylation clear. Yeah. Now let us use this concept and solve this question. Write the structures. Sorry students. Okay. Is this recording or not? It is recording. It's recording. Okay. They asked me, write the structures of the main products when aniline reacts with the following reagents. What is this? This is acetic anhydride. What is this? It's a pyridine which is a strong base. Correct na? So I don't have place. I'm going to write here only. Take aniline with your aromaticity. Take nitrogen, take hydrogen, hydrogen. Take acetic anhydride. This is your acetic anhydride. Correct na? Yes. There should be a base, pyridine, a strong base because you need HCl out. So where will the bond break? Exactly the bond breaks here. Exactly the bond breaks here. So first compound which I get is NHCOCH. What is the name of this compound? This is called acetanilide. Acetanilide or N-phenyl ethanamine. N-phenyl ethanamine. Okay, easy. What else is out? Acetic acid is out. Acetic acid is out. Correct now? That's so. What is the main product? They ask you. So you write main product is acetanilide or N-phenyl ethanamine. Done. Done. Easy. Such questions are asked. Little bit difficult questions are this. Read this. An organic compound A of molecular formula, this one, undergoes a series of reactions as below. Write the structures of A, B, C, D. This was given in Allahabad paper it seems. Let's see and solve such questions. It's okay. Easy. Question concept is the same. First of all, when this question is given to you, what does this do? What is the role of ammonia in this? Ammonia or ammonolysis, correct na? Ammonia is nothing but ammonolysis, which adds ammonia to the molecule by removing your water molecule. I think let's see what it is. Next, bromine in sodium hydroxide is Hoffmann's bromide reaction. This is acetylation or acylation reaction. Lithium aluminum hydride is a reduction reaction. Aqueous bromine is electrophilic reaction, electrophilic addition reaction. Can we start? Yes. So they have given C7H6O2. What is C7H6O2? Basically 2 oxygens means it is an carboxylic acid or a benzoic acid group. This is benzoic acid, which is option A. Chalo, let us start. I am taking benzoic acid. This is option A. This is reacting with ammonia and you are heating it. So what will happen? water molecule is out and you are going to get benzamide. Correct, na? C6H5CONH2. Correct. One second, students. One second, please. One second. I'll just drink water. Sorry. Alright. Now let's come back. Yes. So I'm getting a molecule that is benzamide. What is this molecule? This is basically they just gave me nothing B, nothing. B is the next molecule. So benzamide I am treating with bromine with sodium hydroxide. Hoffmann's bromamide, I'll be getting a product with 1 carbon less. So what will I get? Carbon gone, and I'll be getting aniline, which is B. To this aniline I am using or adding your acetamide, CH3CO acetamide, no, acetic anhydride, right? This is what happens. So this hydrogen, one hydrogen and one more hydrogen breaks the bond and you get one acetic acid, and this complete goes and adds, that is your acetanilide is going to form. What will happen? You will be getting your NHCOCH3. So what is this molecule? This is nothing but acetanilide. That's nothing but N-phenyl ethanamide. N-phenyl ethanamide. This is C molecule. C. That's all. C is over. Chal. Next. What did they do? They have taken this benzamide and they have introduced lithium aluminium hydride in the presence of ether. So what is this molecule? This is nothing but reducing agent. What will it do? It is going to give, they already gave, no, they didn't give, D. It is going to give me benzylamine, means oxygen is lost, hydrogen is added, because reducing agent is reduction. You will be getting NH2. What is this? This is benzylamine. Okay. Now C6H5NH2, whatever B, they have introduced bromine water, that too it is aqueous. Aqueous means compulsory. 1 second, students, I'm getting a call. Sorry. 1 second, please. Okay. So aqueous bromine is nothing but, it's going to add your bromine atom, goes and substitutes at all the three sides. Ortho bromo 2,4,6 tribromo 6 tribromo aniline. Correct na? Yes, this is 3E. This is A, this is B, this is C, this is D, and this is E. That's all. That's all. So go back, before we go to this question, go back and write here what are A, B, C, D. A molecule is benzoic acid. Write the formula. I am not writing. Next page I have written. B is nothing but aniline. C molecule is acetanilide, because the examiner will correct it here only. D molecule is your benzylamine. E molecule is your 2,4,6 tribromo aniline. That's all. These are A, B, C, D. 100%. It's a 5-mark question. Careful. Full mark. Yes? Yes. Let us go and see the next question. If you have not understood, please ask me. Chal. Next question. Illustrate the following reactions giving suitable examples. Acetylation of amines. You are adding acetyl group, na? Simple. You are taking amine, nitrogen, hydrogen, acetyl group, CH3COCl, HCl. You are adding a pyridine base to go for make the forward reaction, comes out as Cl. You will be getting, I am doing the same reaction. Reason, I want everyone to get perfect with the reaction. I don't mind writing again and again, but your concept should be clear. Correct? Name everything, please. If you don't name, you will lose mark. Done. Done. Over. Chal. Next question. The final product C of the C obtained in the following reaction. Simple, same question almost. This is acetic anhydride, AH. This is bromine in the presence of acetic acid. Okay, bromine in the presence of acetic acid means you are trying to add bromine, simple, at the ortho position. Water molecule you are trying to do, trying to, in the acidic medium rather, you are trying to add what? Acid. Let us see what we are going to do and see the structure. Shall we do the reaction? Chal. Careful. First, what did they give me? Okay. Solution. They have given me amine and CH3 group. So let me take out here, let me make hydrogen there, H and H. So acetic anhydride AC2O is nothing but acetic anhydride. Break the bond, and this CONH goes and adds here. So I'll be getting CH3 is here only, where NH, CO, CH3. Then what will I do? I will add bromine in the presence of acetic acid. So what does it do? It goes and occupies at the ortho position without changing any group here. Ortho position. Then I am doing hydrolysis in the presence of acidic medium. So this bond is broken and your NH2, CH3 and your Br group is back. Got it? Yes. Go back and see which option is correct here. Which option is correct? Which option? C. What they are asking you, what is C obtained? C is the same thing with your Br. You see? This is option C. Which is A in this? This is A. Which is B in this? This is B. Okay. Chalo. Next question, students. Chalo. You see? This is blank. Okay, no, this is not blank. I should do a question. I should do a topic. So acylation is clear. Next type of reaction is carbyl amine reaction. Carbyl amine reaction means what? Careful. So only aliphatic and careful. Only aliphatic and aromatic primary amines. Only aliphatic and aromatic primary amines when you are heating with your chloroform in the presence of a base, ethanolic potassium hydroxide. Ethanolic potassium hydroxide. When you are heating chloroform and base, you will be getting isocyanides, or they are also called as carbyl amines. Isocyanides or carbyl amines. Okay. Chalo. Reaction is this. Reaction with chloroform, KOH, give you RNC. Easy. It is actually how, ma'am, how is the product form? I'm not giving the mechanism. I did this in a video. I'm balancing it. Okay. This is yours. Careful. Secondary and tertiary will not give this test. Remember, only primary aliphatic or aromatic amines will give this test. Okay, there is a formation of an isocyanide here. Okay, now careful, understand the concept. Carbyl amine, we are going to solve this question. Chalo. An aromatic amine, an aromatic compound A of molecular formula this. It undergoes a series of reactions. Write the structures of A, B, C, D, E in the following. Okay. What is this bromine and KOH doing? Yes, bromine KOH is Hoffmann's bromamide reaction. Correct? HB. NaNO2 and HCl, it is a conversion of aniline to BDC. Correct, na? Aniline to BDC. Okay. Here Ki, the role is nothing but nucleophilic substitution reactions. Nucleophilic substitution. The nucleophile is substituted. Chloroform in sodium hydroxide is nothing but your carbyl amine reaction. Correct. What is the role of methanol in this case? Basically, your methanol, whatever is there here, it will try to or help in forming. Okay. Basically, ethanol, it acts as a reducing agent here. I'll show you reducing agent, and it will facilitate decomposition of your BDC to BDC. I'll show you what it is. Shall we start the reaction? Okay. First one, C3H7O they said. Okay. Okay. Chal. What is C3H7O? C3, 3 carbons. They said C3 or C7. One second, students. They said C7H7ON. They said okay. Chalo. C7 na. Okay. So that means there is a benzene ring C6H7NH2. Done. This is benzamide. Now what did I do to this benzamide? I have added bromine and KOH. 1 carbon less I should get. 1 carbon less. 1 carbon less is my aniline. Correct? This is my aniline. Okay. Did they name it? They didn't name it. Next, they did, or they given NaNO2 plus HCl. What is this? At 273 Kelvin, you are converting aniline to BDC, N2Cl. Correct? This is, which is A in this case. This is A. After converting BDC, then they said this is B. This is BDC. This is B. To this BDC, what did they do? They have introduced ethanol. Ethanol is your reducing agent. What does it do? It's going to remove the nitrogen gas, the electronegative atom, HCl out, and you will get benzene. Okay? It takes out. So nitrogen gas is also out. HCl gas is also out. Benzene. Okay? Now what is this? Benzene is C molecule. A, B, C are over. Then this aniline, they have treated that aniline, primary aromatic amine, with chloroform and NaOH. What is this reaction? Carbylamine. So what will this get converted to? Phenyl isocyanide. Correct na? Phenyl isocyanide. What is this molecule? This is D. Correct. Now BDC, whatever is there, you are trying to treat it with Ki, which is nucleophilic substitution reaction. So iodine and chlorine are replaced. I'll be getting I. This is E. This is iodobenzene. Easy, easy. All are over, all are over. Before we go to this question, go back and write A, B, C, D, E. Go back and write here. Write A. What is A? Please write the structure, students. I am not writing the structures. Benzamide. What is B? Is your BDC. We need to write the structure in the exam. C, benzene. D, phenyl isocyanide. What is E? Iodobenzene. Easy? Very easy question. Very easy. This is the complete reaction. Hope this is clear, and hope students, more and more you practice, it will become easy for you all. Is it okay? Easy? Very easy? Careful. Chalo, A, B, C, D are done. So I will go to the next question. This question again before we solve this question. Okay. A, B, C, once you get this question, first understand what. Ammonia is trying to condense water and it will form amide. This is Hoffmann's bromamide reaction. This is carbylamine reaction. Carbylamine reaction. CR, carbylamine reaction. Simple. Take this acid. Take N, write like this, NH3. It will be easy for you. Remove this water molecule when you're heating it, and you will be getting your amide, NH2. This is A. Then you are introducing bromine, 1 carbon less you get, that is nothing but amine. This is B. Then you are trying to use carbylamine, where you will be converting the amine into isocyanide. This is C. That's all. A, B, C. Easy? Very easy. One more question. Chalo, let us do one more question based on that. Write the structures of A, B, C, D. Okay. This is what type of reaction? Nitration. Okay. This is what type of reaction? Reduction. This is what type of reaction? In carbylamine reaction. This is what type of reaction? Reduction. Correct? Na? Shall we write the products? Chalo. First thing, A to E. Did they give me any clue here? Okay. They gave E is nitromethyl-aniline. They gave a clue, no? Go back. E is nitromethyl-aniline. E is N-methyl-aniline. Okay. This is E. N-methyl-aniline. Correct, na? Secondary atom. N-methyl-aniline. N-methyl-aniline. Okay, easy. Chalo. Now this is which one? This is E. Then I have to go back. One second. Okay. I have to go back and write. Go back to the reaction. E, before that D. That means isocyanide, I got it from chloroform and sodium hydroxide, NaOH. So this is phenyl isocyanide, NC. Correct, na? Because same molecule I took. Then I went back. Then what did they do to phenyl isocyanide? This is which molecule? No. One second. No, mistake, na? This is okay. Here I should get phenyl isocyanide. Sorry. I should take out this. Here. Okay. This is phenyl isocyanide. Okay. Then what did they do? From where I will get phenyl isocyanide? From C, na? Okay. From C. Right. That means primary aromatic amine. So I'll get primary aniline. Correct. Okay. Done. From that we went back and I took SN by HCl. So nitro compounds in the presence of on reduction gives me aniline. Correct, na? Yes. Then go back. HNO3 and H2SO4. You are doing nitration to benzene only, no? Nitration to benzene. So benzene. This is A. This is your B. This is your C. This is your D. This is your E. Easy? Very easy. The question is easy? Very easy. Correct, na? All. So go back to this one and write A to E like this. A, B with the structures. C, D, and E. Is it okay? Easy? Chalo. Before we go to the next reaction, after acetylation, till now what did we learn? We have learned acylation reaction. We have learned carbylamine reaction and related questions. Now we are going to learn reaction of primary amine with nitrous acid, HONO, HNO2, with HONO, HNO2. Right? I'll take a short break and then come back. Alright, now let's come back and do this reaction, that is reaction of primary amine with HONO. So HONO or nitrous acid, anything is the same. I can write the same nitrous acid as like this. Now that's why we call it as HONO. So basically both your primary aliphatic amine as well as primary aromatic amine, both are going to react with this HONO or nitrous acid. So what is the speciality of this is simple. In this particular thing, both of them rather they're getting converted into your if I taking RNH2, they'll get converted to RN2X. If I'm taking this one, they're going to convert in RN2X. So BDC rather. Further, this RN2X, when you heat it on in the presence of water, H2O or HOH, you will be getting alcohols. Okay, N2 and HCl. Okay, this also further on heating, certain conditions where you get phenol your N2 and HCl. This is your HONO reaction. So this is a conversion of aniline to BDC, BDC to your alcohol further. Okay, so alcohol phenol rather. So let us see the reaction. So basically simple, nothing much. If I am taking RNH2, okay, I am taking hydrogen. So here HONO we are writing, right? So here this whole reaction occurs in the presence of NaNO2 and HCl. This is what is the most important thing. Here first, in the first step, I'm not doing the mechanism, are N2Cl. I did this mechanism in one of my one-shot videos. You can watch it. Further, this on hydrolysis, your HCl is out, nitrogen gas is out. Nitrogen gas is out and evolve, and HCl is out, and you'll be getting your alcohol. Okay, this is your reaction. Now same thing if I'm taking your aniline rather. Okay, ma'am, does it form phenol? Yes, it forms phenol gradually. There are certain conditions on that. And again I'm taking HONO. Again I'm introducing NaNO2 plus HCl. Okay, so there's one certain temperature at 273 Kelvin to 278 Kelvin. Okay, 78 Kelvin. What will this do? This will convert into a molecule called BDC into Cl. This is your BDC, benzene diazonium chloride, plus your NaCl plus water molecule is here. You got it. Ma'am, where is phenol? In further examples when I'll show you where it is forming phenol. Okay, this is clear. So basically reaction with HONO is to convert your aliphatic or aromatic amine. But what is difference here in aniline is you're going to take your cold conditions. Here in aniline you're going to take cold conditions. This is important here, so don't get confused. Here in this one we are not mentioning separately cold. In aromatic you're going to use the cold conditions. Is this clear? Reaction with nitrous acid. So this is your reaction with nitrous acid. Okay, this one. This is which reaction? This is the third reaction which we have done. ABCD, the third reaction for preparation of amines. Done. Now we are going to learn the fourth reaction and almost last reaction, that is reaction with careful, I'm writing Hinsberg reagent. There are a lot of question on Hinsberg reagent because it's easy actually, but anyhow I'll just tell you what is that. Hinsberg reagent. So Hinsberg reagent is also called as benzene sulfonyl chloride. Benzene sulfonyl chloride. What is the formula of this? It is C6H5SO2Cl. This is yours. So what is this benzene sulfonyl chloride do? So benzene sulfonyl chloride, if I have to take careful, it is going to react with both your primary and secondary amines. Careful, I am writing benzene sulfonyl chloride C6H5SO2Cl. Yes, combines with both your primary amines and it also combines with your secondary amines. So when this reagent combines with primary amines and secondary amines, what do? They are going to form compound called sulfonamides. What are they called? Sulfonamides. So once again, Hinsberg reagent converts primary amines and the secondary amines into a product called sulfonamides. What happened to tertiary amines? Basically, tertiary amines, there is no reaction. When they react, it doesn't show anything. Reason, there are no hydrogens in this, no hydrogen atoms in this. That's why it doesn't show. Is it okay? Clear? Chalo, let us start carefully and do the reaction and substitute the same reaction. First, I am going to take benzene sulfonyl chloride. So this is my aromatic ring. Okay. Then to this I have SO2Cl. Done. Now I am adding one primary amine. Primary amine means how many hydrogens? I have 2 hydrogens, 1 degree amine. So what is going to happen? In the first case, you are going to take out that HCl. And what will happen? You will be getting your ring. Alright, ring, and in that you will be getting SO2 is the same, and your N, H and R. What is this compound called? This is called Careful, I've just added it. I took out HCl and I added this molecule. What is this called? N. Okay, this is secondary carbon atom, the secondary nitrogen, because only one hydrogen, we add N. It is attached to alkyl group, and this one is attached to benzene sulfonamide. N-alkyl benzene sulfonamide is a product formed with primary. Correct? Yes. Now, in this, whatever hydrogen is attached to the nitrogen, no? This is highly acidic in nature. Why it is acidic? Because there is an electron withdrawing group which is present. The sulfonyl group is there. Now, this is called sulfonyl group. This sulfonyl group, it is attached. That's why what does it do? It tries to drag the electron. Highly acidic, strong acidic, because this is there with the electron withdrawing group. Means what will happen? It will try to drag the electron density towards it. When it drags, no, H plus, the bond is broken, it releases the proton. Correct? Yes. So the hydrogen atom in the nitrogen formed in sulfonamide is acidic because of presence of strong electron withdrawing group, that is SO2, and this is soluble in alkali. This is soluble in alkali. Remember, it is soluble in alkali. It is soluble in base, because this will be using for your distinguishing test. That's why I am trying to tell you this. Next, this is primary now. Now let us do with 2 degree. Take same benzene sulfonamide. Okay, benzene sulfonamide. You are trying to use SO2Cl. You are trying to use NHR and R. This is my secondary amine. What will happen? Your HCl is out. Do we have a page? Yes, we have a page for tertiary. HCl is out. And what is left? The whole molecule comes and attaches SO2, NH. Now, careful. Here in this case, there are no hydrogens, basically only one hydrogen that has gone up. So, NR and R plus your HCl. Now, name this compound. There are no alkyl group, no hydrogen group. That's why it is N comma N. Then dialkyl. 2 alkyl groups are there. Then benzene. Then sulfonamide. Okay. Benzene sulfonamide. N comma N. Dialkyl benzene sulfonamide. Now this one is insoluble in alkali. If they ask you to write the differentiating test, this is important. Okay, that is soluble. Primary was soluble and secondary is insoluble. Now what will happen to your tertiary? Do I have place here? This is for the next one. Okay, so tertiary, shall I write here, students? Yes, tertiary. Okay, so do I have anything? Yes, there is certain thing, we will learn it. So for tertiary, 3 degree amine with Hinsberg plus Hinsberg reagent. Now you only tell me Hinsberg reagent is this. Correct? Benzene sulfonyl chloride. In tertiary you have 3 R groups. Okay, this is tertiary. Will anything happen? No, because HCl has to come out. No, there is no reaction at all. No reaction at all. Easy, very easy. Just like this. This is secondary, this is tertiary. Done. So 1 degree and 2 degree amines react with Hinsberg reagent. 1 degree is soluble in alkali and 2 degree is insoluble in alkali. Correct now? In alkali. Is it okay? Easy? Done. Now we are done with the preparations of your primary amines, rather your amines. So what did we learn in the preparations? Careful, we are going to solve a lot of questions. First one I did acylation reaction. Done. Second one I did your carbylamine reaction. Third one I did reaction with HONO. Fourth one I did reaction with C6H5 Hinsberg reagent SO2Cl. Correct? Now we are going to start with the last type, that is ring substitution reactions or the aromatic amine reactions. Aromatic amine reactions. So in aromatic amine reactions, that's nothing but your ring substitution reactions. So basically aniline, aromatic amine is your aniline. So aniline undergoes electrophilic substitution reactions. Yes, because of resonance, we have seen the resonating structure of aniline, right? It undergoes resonance at the resonating structures at ortho and para positions, where para being more stable. Okay, it is OP directing ortho and para. But careful, first electrophilic substitution reaction, if you see bromine, this is the electrophile. If you are seeing in aqueous solution, you get 2,4,6 tribromoaniline. Correct? This is your nitration mixture. Here the electrophile is NO2 plus. Ortho position, para position and meta, because it is meta directing group also, because it is electron withdrawing. So among which para is major product, meta is rather the next major, and ortho is the minor product, because nitro is always electron withdrawing and meta directing group. Next comes your sulfonation reaction, where SO3H is your electrophile. First, as I said, in sulfonation, it's going to attack at the para position. First it will form the salt, then it will direct to form a para position, then that is in equilibrium with the zwitterion. Zwitterion, where both the negative and the positive ions are there in the zwitterion. Okay, clear? Yes. So this is your, just for you to understand, there's no big explanation in this. This is just your electrophilic substitution reactions. So careful. Done. Now after that we have the last part of your chapter, that is diazonium salts. Diazonium salts is nothing but benzene diazonium chloride. In this your X, that is we call it as BDC. Okay, this is a very important topic and easy. So BDC, benzene diazonium chloride, actually the chloride can be the X can be chlorine, bromine, bisulfate, BF4, anything. How am I preparing? I am taking aniline, I am adding NaNO2, this is HCl at 0 to 5 degree. So whenever you are adding NaNO2 and HCl, first aniline gets converted to BDC, further NaCl and water. Got it? So ma'am, simple reaction, I just gave you the chart here. This BDC undergoes different varieties of reactions. Okay, different varieties of reactions. Like if you are taking copper chloride and HCl, this X is replaced by chlorine. Okay, if you are taking CuBr2 and HBr, X is replaced by Br, we call it as Sandmeyer's reaction, CuCl2, CuBr2. If you add KCN or CuCN, Cn is replaced by X. So these three are called Sandmeyer's reactions. Easy? Easy. If you are doing hydrolysis to this, you are converting BDC to phenol. If you are adding ethanol, which is a reducing agent, BDC to benzene. If you are adding again H3PO2 plus water, same reducing, BDC to benzene. These are all conversions. This will be useful for your conversion students. Careful, all are for conversions. If you are using HBF4, F is replaced by the X. If you are using KI, I is replacing the X. If you are using CuBr, don't get confused between this. Here it is Cu2, Cl2 and HCl, that is Sandmeyer's. Here Cu by HCl, that's nothing but Gattermann's reaction. So the nitrogen gas escapes out in all the cases when you are heating it. Careful, everywhere nitrogen gas should be out. Then the remaining electrophile goes and the remaining nucleophile goes and substitutes the halogen. Here in this case bromine, here in this case chlorine. Done. Okay, easy? Easy. Now careful, understand. With these reactions, whatever I am doing, whatever I am explaining here, we will start applying in the questions. And there is one more important reaction, coupling reaction. Coupling. So this is one coupling. Before we go to such questions, carefully understand. So BDC, the famous reaction, is a coupling reaction. What will happen in this? There is a coupling or two means it forms a couple. What forms a couple? One is BDC and phenol. One is BDC and aniline. So in both the process, what will happen? You're careful. The H, careful students, don't get confused. This happens in the presence of a base. This happens in the presence of an acid. So what are we removing? We are going to form a bond with nitrogen to this ring. Water molecule is out and your Cl ion is out. Got it? Means you're coupling two rings. Here also we are trying to remove the chloride ion out, water molecule is out, and you're coupling both the rings. So nitrogen with a double bond, nitrogen with double bond. Here what is most important thing is, when BDC combines with phenol, it forms an orange color dye which you will be using as a functional group test in lab. That's called para-hydroxyazobenzene. Azo means this group. If you are trying to add BDC with aniline, here again double bond. NH2 and OH groups are retained here. This is forming yellow dye. This is orange dye. This is yellow dye. This is called para-aminobenzene. Is it okay? Okay. Easy. Easy. So what is important here is the differentiation test with BDC phenol, BDC aniline is both form azo compounds. This is orange dye because this will be given in the paragraph based question. So you should remember that. Okay. Done. Done. Chalo. So careful. Understand. Anywhere any doubt, please ask me. Let us start with the questions. We'll start solving the MCQ questions. Very, very important MCQs. Very important MCQs. How many marks you have? 16 marks you have in your board exams now. So let us start with the MCQs. Right. First one. What is this? NaNO2 HCl. What type of reaction is this? Diazotization reaction. Correct? Okay. Here what are we adding? This is what? Nothing. Simple. You are trying to do coupling reaction. You are adding this. This is nothing but coupling reaction. Coupling reaction. Get C. What is the molecule they are asking? Chalo. Let us start solving it. First, step 1. C6H5NH2. What are you doing? You are trying to add NaNO2 HCl. What do you get? This is NaNO2 HCl. You try to get BDC along with your NaCl plus water. Now what did you do? You have taken that BDC. This is your A molecule. This is your B molecule. In step 2, you have added, take that BDC. I am going to show it in this way. C6H5N2Cl plus I am taking this molecule here. Okay. So what is that molecule? Basically CH3 taken twice, ring. Okay. CH3 taken twice, and this. Okay. Correct, huh? Okay. Nothing. Simple. First you are going to boil this N2 gases out. Okay. Along with that, your hydrogen gas also, HCl also comes out, because Cl should come, both should couple, na? Yes, both. Then what is the left out thing now? Left out thing, both the rings whatever you are getting, this and this are going to couple. This and this are going to couple, this and this, and finally this also gone. Nitrogen and nitrogen coupling. Come back and see which compound is that. Nitrogen and nitrogen, because you have two nitrogens here na. One nitrogen has come out. There is one nitrogen here. So the nitrogen atom comes out, comes and joins this. Go back and see which one. See here. You have your N and CH3. Okay. Sorry. Now come back. You have two. Here there is one alkyl group in the first ring. Do we have this? No. So this is ruled out. Here also there is an alkyl group. This is also ruled out. Here there is CH2 group. We don't have CH2 group here. Correct, no? Yes, this is also ruled out. So what is left out? This ring. That's all. So option C is the correct one. Easy? Very easy. Chalo, next question. Let us understand the next question. Yes. Which of the following statements about primary amines is false? Okay. Alkyl amines are strong. Which one is false? They're asking. Okay. Alkyl amines are stronger bases than aryl amines. Let me explain this. Taking the statement. First one. Alkyl amines are stronger bases. RNH2 is a stronger base than ARNH2. Is it right? Is it right? Yes, it is right. Correct now. Because here this is electron releasing group. Here electron withdrawing group. So this is plus psi effect. So this is, it will easily donate electrons, more basic. This is resonance and less basic. Correct now? So first statement is correct. Perfect? Yes. Next statement. Alkyl amines resist reaction with nitrous acid to produce alcohols. Is it wrong? But it is right now. Alkyl amines are going to react with HONO or NaNO2 and they form BDC, and further hydrolysis they will form alcohol, nitrogen gas and HCl. So the second statement also is right. They ask me false, na? Okay. Third one. Aryl amines react with nitrous acid to produce phenols. Okay. Basically, if I have to say phenols, yes, I told you earlier, na? Phenols. Normally, they said aryl amines react with nitrous acid to produce phenols directly. No. What happens? Aryl amines, when they react with NH2, with HNO2 and HCl, they don't form phenols. They first have to form BDC. But what did they say? They said they produce phenols. That's further. But as of now, no. They stopped at BDC only. So this statement is wrong. Last one. Alkyl amines are stronger bases than ammonia. That also is correct, no? Yes. RNH2 a stronger basis than NH3. Perfect. This is plus psi effect, more basic. Means they're trying to release the electron. This is also correct. This is also correct. But here it is BDC. That's why the statement option C is false. Is it okay? Okay. Done? Done. Chalo. Any doubt? I think I'm going slowly so that everybody understands it. Those who are learning for the first time also, you can understand it. Correct? Chalo. Next question. This is a blank page. I'm going to the next page. Okay. Which of the following is most stable diazonium salt? Most stable diazonium salt. Okay. How should I know this is most stable? We learnt, na? Among that BDC is the most stable. This one. Correct, no? Any doubt in that? This is not BDC. Alkyl amines will not form BDC. This is also wrong. This is also wrong. So option B, that is C6H5N2X. That's nothing but stable diazonium salt, N2 plus and X minus. So this is BDC. BDC or benzene diazonium chloride, bromide, whatever it is. Next question. Method by which aniline cannot be prepared. Okay, aniline cannot be prepared, they asked. Okay, so I know the different procedures now. So let us start one. First one, what did they say? We will do the first one here, second one next week. Reduction of nitrobenzene with hydrogen, palladium and ethanol. Nitrobenzene, I am dealing with reduction, palladium and hydrogen. What will happen in palladium and nitrogen? Basically, you are adding 3 hydrogen atoms. So C6H5NH2 will get and water molecule. If I balance this 3 hydrogens, this is 2 hydrogens. Yes, aniline is prepared. I can prepare. Perfect. Next, potassium salt of phthalimide. So aniline by potassium. What is potassium salt of phthalimide? Basically, potassium salt of phthalimide is Gabriel phthalimide synthesis. Correct, no? Gabriel phthalimide synthesis basically is used to prepare only primary alkyl amines, not aniline. Correct, no? Yes, primary alkyl amines, not aniline. So this one is wrong. So aniline cannot be prepared by the second method. Third method, hydrolysis of isocyanide. Let us write that reaction. It will be a revision. H5NC plus water plus HCl is going to give me C6H5NH2 plus formic acid. Okay. Balance this 2 and alright. Third, D1 is what? Degradation of benzamide with bromine in alkaline. That is Hoffmann's bromamide. Na? So it is Hoffmann's bromamide reaction. C6H5 in the presence of bromine, in the presence of a base. What do I get? 1 carbon less. C6H5NH2 plus sodium carbonate plus NaBr plus water molecule. Correct, no? So balancing part, if I do, this is sodium hydroxide 4, this is NaBr. Chalo, this is Hoffmann's bromamide. This also is preparing aniline. That means this also is preparing aniline, this also is preparing aniline. So the answer is option B. So just analysis. Chalo, next question. In the chemical reaction, CH3, CH2NH2, chloroform and KOH, A plus B. Okay. So before I go to this reaction, let us understand what is A and what is B. First of all, chloroform and KOH, what is this reaction? It is carbylamine reaction. So carbylamine, what does it give? C2H5NH2 with CHCl3 and KOH will give me isocyanides, na? C2H5NC plus KCl plus K2CO3 plus water. That's all. So what is given to me? This is wrong. This is also wrong. Yeah, this is correct because this is the next product. This is also wrong. So option C. Okay. Chalo. Yes. Next question. Which of the following compound will give significant amount of meta products during mononitration reaction? Significant amount of meta product. Okay. So basically nitration means addition of an electrophile NO2 plus. Okay. Meta product, they said. Among all, first of all, what should I remember is nitration, whatever concept you're doing, whenever you're adding an electrophile, nitration means addition of NO2 plus in the presence of concentrated HNO3 or sulfuric acid. This should happen in a acidic medium because H2SO4 and this one, this will happen in an acidic medium. Okay. So in strong acidic medium, what is going to happen? Aniline, whatever is there, this gets converted to anilinium ion. Anilinium ion, NH3 plus. This anilinium ion, this is aniline and this is your anilinium ion. NiLiNium, anilinium ion. This anilinium ion is meta-directing group. So for this reason, what will happen? For this reason, aniline will give meta product. So that is what they asked now. Among all this, aniline is that compound because this forms anilinium ion and it is meta-directing. Mononitration product. Next question. The final product. C in the following sequence of reactions. Now what are you doing? You're taking aniline. You're adding bromine water. That's nothing but 2,4,6 product. Then what is this reaction? What is this reaction? NaNO2 and HCl. It's conversion of aniline, diazotization reaction. Conversion of aniline into your BTC, correct na? Diazotization reaction. And adding HbF4 is called Bals-Schiemann reaction. Bals-Schiemann reaction. This is okay reaction, but nothing but fluorination. Okay, this is nothing but fluorination. Chalo, let us start. First thing, aniline. Sorry, I don't have place. Okay. First thing, aniline with bromine water. Is this a different question? Different question. Aniline with bromine water. I will write here C6H5NH2. Okay. With bromine water, what do I get? Basically this compound, correct na? 2,4,6 tribromo aniline. This one. Now I am doing BDC to this. When I do BDC, the same molecule is there only. It's like that. And I get N2Cl because Cl I am using. This is B. This is A. This is B. Now to this B, I am adding what? HbF4. HbF4. You're replacing the this one Cl molecule with your HbF4. So first thing, what happens? The nitrogen gas, the BF3, everything will come out. Careful. The ring is like this. Bromine, bromine, bromine. Along with this, nitrogen gas out, BF3 out. Okay, 3 fluorines out. So what is left? Only one fluorine atom from here comes and adds here. What is this called? This is called 2,4,6 tribromofluorobenzene. 2,4,6 tribromofluorobenzene. Now go and see the option now. What is C they said? The option 2,4,6 tribromofluorobenzene. This is the answer. See this. This is C. Okay. Done. Done. Perfect. Chalo. Next question. Little bit difficult. No, it's easy actually. There's nothing in this. What is this reaction? This is Hoffmann's bromamide reaction, HB. Correct. What is this? This is nothing but your benzylation reaction. Benzylation reaction. Benzylation reaction. Shall we start doing that thing? Chalo. Let us start doing. Don't get confused. It is easy. In case 1, in Hoffmann's bromamide reaction, what is going to happen? Your whatever you're taking this molecule, now copy the same. Copy the same. Okay. Now this C double bond O NH2, 1 carbon less. So you're adding what? You're adding NaOH and bromine. Correct na? NaOH and bromine. So this is what? 1 carbon less. Take this CH3. Take this benzene ring. 1 carbon less. That means this becomes your, see, normally your CO is there, na? The CH3 is there, that goes and NH2. Along with this, you have your sodium carbonate, you have your NaBr, you have your water molecule. So if I have to balance this is 4 sodium. If I am adding like this, then this is 2 NaBr and this is 2. Okay, done. Then what happened? We are doing acylation reaction. Just you're condensing it. Take this ring. This is your benzylation rather, and your NH2. This one I am taking, and I am adding this acyl group Cl, C double bond O, that ring. What is removed now? The presence of a base. So your HCl is out and you get a product joining these two. What is this? This is your OCH3, then your NH, then C double bond O, and then C6H5. Okay. What is the name of this compound rather? This is called N-benzoyl para-toluidine. Para-toluidine. Go back to the option and see which option. Okay, yes, this molecule. Correct now? Yes, this is para-toluidine. Rather, if I have to, no, this is called as N-benzoyl para-toluidine. That's all. Okay, done. Chal, this is the question. Careful, light. Right. Then next reaction. Which of the following reactions are going to form benzyl amine? Okay, one second, students. One second. Which of the following reactions form benzyl amine? Okay, no problem. So this is what agent? This is reducing agent. Okay, I can get the answer here only. See this. CONH2 in the presence of reducing agent LiAlH4. Then hydrolysis you are doing now. Reducing agent no. So this will remove the oxygen and add hydrogen. That is nothing but my benzyl amine. This is nothing but my benzyl amine. Okay. Chalo. So first one, which of the following forms? First one. You see? So this is nothing but reduction of amide. Okay. Chalo. Next question quickly. Bromobenzene can be prepared from benzene diazonium chloride by its treatment with water. We did this thing na, this particular thing we did no, flow chart. See, this is from this flow chart. Where is that my flow chart? My flow chart, this one, this flow chart. Okay, from this flow chart they have asked a question. Let us go to that question and solve it. Okay, bromobenzene is prepared from benzene diazonium chloride from what? Do I have place here? Yes, I have. Let us solve. First of all, bromobenzene. I have to prepare C6H5Br. Okay. From where they are saying? Simple. And all these reagents, bromine means I have to take Cu by HBr only, na? Correct? But one problem. This one and this one, which one to pick? That's the problem. Correct, na? First of all, bromobenzene is prepared from BDC. That I know. C6H5N2Cl. Correct, no? So, now, to this N2Cl, if I add CuBr plus HBr, what will happen? I'll get C6H5Br along with this N2 and CuCl. Now, what is this reaction? This reaction is nothing but your Sand-Meyers reaction. Ma'am, why can't I use this? We will justify that. Sand-Meyers reaction. Here what is happening? The diazonium group, this N2 plus is there, no? It is replaced by Br. That's okay, that's clear. And nitrogen gas escapes out and remaining. So this is, if this escapes, this is more efficient. Now why remaining options are not correct? Why this is not correct, this is not correct, this is not correct? Let us justify. Which is the correct answer now? Option C is the correct option. Correct now? Option C is the correct one. Now why remaining? No. Reason, Cu by HBr. Why it is incorrect? Here Cu does not facilitate, only that will not facilitate diazonium salt. You want CuBr and HBr. So only Cu cannot generate diazonium salt, BDC. You require that. Next, bromine in the presence of H nu. What is this reaction? This is free radical bromination reaction. Free radical bromination reaction. Not for BDC. This also will not give. Next, last one. Bromine in CCl4. Bromine in CCl4. What is this? This is electrophilic aromatic bromination reactions. Electrophilic aromatic bromination reactions. So this requires basically, when this is there, no, you require catalysts like FeBr3 and AlBr3. You require these catalysts. Okay, this is not for your BDC. Reason clear. So whenever you want bromobenzene, you require this catalyst, that is Sand-Meyer's reaction. So option C. So everything you need to justify, student, then only chemistry it is. Shut up. Next question. Acetamide and ethanamine can be distinguished by what? Acetamide and ethylamine. Whoa. By which reactions they can I can distinguish, they're asking. I'll tell you how to do. Careful. All I'll explain, you understand. Okay. Both we'll write. First, what we'll do, we'll make the reagent here. Okay. Here we will make acetamide. What is acetamide? Here we'll make ethylamine. Here we'll make the distinguishing, whether it responds or not. Distinguishing factor. Okay. Distinguishing factor. What is this? Acetamide is CH3CONH2. Ethylamine is C2H5NH2. Okay. So let us make a vague line. Sorry. Anyways, okay. What is the first reagent? Aqueous HCl and heat. So aqueous HCl and heat. Here acetamide will get converted or hydrolyzed to acetic acid. It is hydrolysis reaction and ammonium chloride I get. Ethylamine, what does it do? It forms a salt. When it combines with this one, no, it will form a soluble salt. You will get one salt like this. So here both are trying to, like, you are getting acetic acid, here getting salt. There is no clear differentiation. I can't know clear differentiation with this test. No clear differentiation. What did they ask? Which one I can distinguish correctly, they said. So I can't differentiate much here. This is over. Next one, aqueous sodium hydroxide and heat. This one is what? Next one, Hoffmann's bromomide degradation. Correct na? This is Hoffmann's. So acetamide in Hoffmann's, you will get one carbon less atom, methenamine. Here no reaction. So I can differentiate here, no? Yes, clear differentiation I can see here because no reaction, no? Done. So second, Hoffmann's bromide degradation I can take it out. This is one clarity. Third one, what did they take? Acidified KMnO4. Acidified KMnO4. Now tell me, amides, no significant oxidation because it is an oxidizing agent. No significant oxidization. So I can't take this test. No visible clarity. I can't differentiate. No visibility. Visible. I can't differentiate. Visible distinguishing test. I can't take this. This is also ruled out. Next one, last one, bromine water. No reaction. Here also no reaction. So I can't take this. I can't consider, no consideration. I can take this also for distinguishing. So what is the one which is clearly differentiating? Hoffmann's test. Correct now? So go back. Which one test? This one. So option B is the correct one, which gives me distinguishing between acetamides and ethanamide. Okay, amides. Next test. Next question. The order of reactivity of halides with amines. Halides. Okay. So basically, I think easy question only. All are halogens. Among all this, which is correct, they're asking. I'll mark this. Why? A reason I can give you. When I talk about X is equal to chlorine, bromine, iodine. Iodine, what is the best option? What is the best thing? Among this, Ci bond is the weakest bond. Weakest bond among all. Then Ci is, or I molecule is largest size. Correct, na? Because it is largest size, bond is weak. Next, it is best leaving group. It easily breaks the bond. Correct. Among this, easy and most important thing is, once I break the bond, it can easily react with halides. Easy to react with halides. Correct now. Whichever comes, it can easily substitute. So among this, Ri is more, Cl is less than Cl is. This is more electronegative. So the bond is strong. Bond is strong. That's why it's not easy. Okay, clear? Chal, this page is blank. I already wrote that. Done. Okay. Next question. Which of the following does not affect the Kb of an organic base? Okay, Kb. I'll give you the complete analysis in the next page. Kb of an organic base. Basically, Kb depends on what they're asking. Very important and very interesting question. Let us take. What is the first option? Plus I or minus I. Correct na? So whether Kb it affects or not. It affects. Why it affects? Because plus I effect. See, normally what happens? If plus I groups are there, electron releasing groups are there, what will happen to the basicity? If plus I groups are there, your Kb value, if electron withdrawing groups are there, Kb value increases. If minus I groups are there, electron withdrawing group, the Kb value decreases. Is it not affecting? Affecting. This is okay. First one is okay. Next one. Solvation effect. Solvation effect. Now you tell me in solvation, this also affects. How it affects? We said na, the solvation of the conjugate acid of the base stabilizes it. Correct no? That means it will influence equilibrium and influence the Kb. That means more solvation, higher Kb. This also affects, right? This also affects. Okay, next option is what? Density. What is density? Density does not affect. No effect. No effect. Correct no? So no effect. No effect. Why? Because density is equal to mass by volume. So no effect on that. The next, the last one, if we see, steric hindrance. Steric hindrance. Now you tell me in steric hindrance, yes, it affects Kb. Why? Because bulky groups, if they are there, steric hindrance, a lot of bulky groups. If bulky groups are there, proton release will become less. Correct na? If bulky groups are increasing, H plus release decreases and Kb value decreases. Okay, done. So which one among everything? Density is a factor which does not affect Kb. Clear? Sure. Next question. Which of the following on reduction with lithium aluminum hydride yields secondary amine? Lithium aluminum hydride is a reducing agent. Correct na? Chal. I want what? Which one? I should see all the reactions which will give me secondary amine. Okay. Chal. Let us write all the reactions. First, methyl isocyanide reduction. Okay. So I need to add both na. Correct na? CH3 NC. Okay, suppose if I add two hydrogens here, CH3, or let us see, I will get NHCH3. This is 2 degree amine. Okay. Next is what? Acetamide. CH3 CO NH2. I am adding hydrogens. What do I get? CH3 CH2 NH2 and 4 hydrogens here. So this is primary amine. Third one, methyl cyanide. I am adding hydrogens. What do I get? CH3, CH2, NH2 and 4 hydrogens. This is also 1 degree. Fourth one, nitroethane. I'm adding hydrogens. This gets converted to your ethylamine. 6 hydrogens, 1 degree. That's all. So go back. They asked me which one on reduction gives me secondary amine. Which one? Methyl isocyanide. Option A. Okay. So done. Next question. Okay. In diazotization of aniline with NaNO2 and HCl acid, the excess of acid is used primarily for what? Okay, what did they say? In diazotization reaction with this, the excess of acid is used for what? Alright, so let us understand the question. Basically, what is that? NaNO2 and HCl. Okay, chal. What is diazotization reaction? Basically, diazotization reaction in aniline, what do you do? Basically, you're going to take C6H5NH2. You're going to combine with NaNO2 plus HCl and you will get BDC. Correct, na? This is the thing, correct? Now, here HNO2 or the NaNO2 rather, the nitrous acid, whatever you're taking, careful, this is the most important reactant. Why? No, basically this is the most important thing which is formed in the product. This is in situ, is generated in situ. Means what? NaNO2 HCl combines, na? What will happen? First it will form HNO2 plus NaCl. See this, first this is formed. So what will happen? The presence of this excess HCl, whatever is there, no? It will ensure that the correct amount of HNO2 is available. You understood? The amount of excess HCl, whatever is there, it will ensure that correct amount of HNO2 is available. That is the work of this HCl. So without this sufficient HNO2, further reaction will not happen. Correct, no? So correct amount they should be there. That is what is your task. So excess HCl, we'll see that correct amount of HNO2 is present. So go back to the question. So what is an aniline diazotized excess of acid? What is its role? Its role is to see that correct amount of, ensure a stoichiometric amount of HNO2 acid. Then only your aniline gets converted to BDC. Is it okay? Chalo, easy. Now next question. Okay, over. So we are done with your MCQs for this chapter. Okay, now I'll be taking you into 1 mark questions, 2 mark questions, 3 mark questions, 4 mark and 5 mark. Okay, I'll meet you in the next video. Alright, thank you. Alright, now let's start with your 1 mark, 2, 3 and 5 mark questions. So basically these questions will be mostly, rather if I have to tell you, they are going to include all your account for the following, such type of questions, and they are going to include give reasons for the following or account or give reasons for the following. They'll ask you identification based questions, identify A, B, C, like that, and such questions. They'll be asking you certain questions, 1 mark questions, very tricky questions. So let us start doing the video. Let's see how we are going to answer the questions. Alright, see this first question. As I said, you're going to identify A, B, C in the given reactions. Alright, so how many are there? Total 5. So it's a 5 mark question. Okay, each carries 1 mark. Chalo, let us start. First of all, CuCN. I think there's no place, but I'll try to add how many ever I can here only. So first thing, CuCN. So it's a substitution, or the nucleophile is substituting this particular nucleophile. Correct. So what do I get? I get C6H5Cn. This is A. Correct. Now, after that, you're doing hydrolysis to this. When you do hydrolysis, nitrile compounds are getting converted to your acidic group C6H5COH. This is your B. Correct. Now, further, you're adding ammonia. Water molecule goes out of this, and you're going to get your amides. Okay. This is your amides with water molecule removed out. Correct. Right. This is over. This is C. The next one, again same, you're doing nucleophilic substitution reaction, so you're going to get CH3, CH2, Cn. Done. This is A part. Then you're doing reduction reactions, so one hydrogen adds here, one more hydrogen adds here, and you are going to get propanamine. Correct? No, this is your B. And HONO, you very well know, amines in the presence of HONO or nitrous acid, they're going to get converted to your alcohols. Correct? This is your alcohol part. This is your alcohol. This is the C part. Easy. Now, C6H5NO2 in the presence of FeHCl. Fe, it's a reducing agent. Reduction happens. So, oxygen is removed, hydrogen is added. So, I'll get aniline here. Okay, done. Then again, HONO, simple amine to HONO at 273 Kelvin. Here temperature not mentioned, so directly I wrote the product. But otherwise, aniline in the presence of HONO gets converted to BDC first, C6H5N2Cl. And after that, you're doing hydrolysis, so this becomes your C6H5OH. This is your phenol molecule. Okay, done. Then ammonia. So ammonia, simple. When you're heating it, water molecule comes out, and you are going to get your amide. Okay, done. Then NaOBr. What is this NaOBr? It's basically your iodoform reaction, correct? Na? NaOI or NaOBr. Simple. So you're going to get primary amines in that. Primary amines. Okay, done. Because it is aliphatic amine, I get aliphatic amine only. Then NaNO2HCl, just your HONO type. So directly they're not writing any heating part. So they're directly saying form the product. So make the alcohol directly. Okay, if they give you 273 Kelvin, then convert it to BDC, then for the hydrolysis your alcohol. Now NaCN, substitute this I with your N, so I'll be getting CH3, CH2, Cn. Then you're doing partial hydrolysis. When you do partial hydrolysis, simple, the first amide forms this one. So here how many are there? 2 molecules are there, so 2, and this is okay. Then NaOHBr, again this is an iodoform reaction which converts amides to your primary amines. Hope this is not covering it. Amides to primary amine. This is iodoform reaction. Correct na? Yes. So basically simple question, students. Simple. What you should remember is whenever you have your any type of reaction, for example, when you see reagents like CuCN or you're seeing KCN or NaCN, what you're going to remember? You're going to do nucleophilic substitution reactions. Just replace the nucleophile in the reactant with this product. Everywhere Cn is a nucleophile. Next, when you're seeing H2O and H+, that means you're doing your acidic hydrolysis, hydrolysis, correct na? Hydrolysis reactions where you're going to add, or that particular molecule gets converted to your acid if it is Cn. Okay, then third one, ammonia. Ammonia is nothing but your, basically ammonia converts your group, whatever group, to amides, correct na? Indirectly, if I have to say ammonolysis, you're adding ammonia to the molecule. And suppose if you're seeing Fe by HCl, any metal atom, simple reduction process happens where you'll be adding hydrogen. Suppose if you're seeing lithium aluminum hydride, this also same reduction process only. Suppose if you're seeing HONO, HNO2, or you're seeing NaNO2 by HCl, all this are going to convert, careful, whichever molecule, the HONO part, if you see, they're going to convert amines to your alcohols. Okay, amines to your alcohols. Then seventh part, if you see NaOHBr2 or if you see NaOBr, that means you're seeing iodoform reaction, correct na? Iodoform reaction where you'll be getting no, iodoform reaction. See, basically what happens is in iodoform reaction that you're getting CHI3. Here we are writing the amine part if you are using the amide. So basically NaOHBr, a stronger base, will convert. So here iodoform reaction is one part if the reactant is different. In this case, it's converting this Br, in this case is converting amide to amine. Correct na? Amide to amine. Simple. Chalo. Next question. Let's see. Complete the following reactions. Okay. So, one after the other. Let us see the first one. What is this? Concentrated sulfuric acid. It is not dilute. So, the first one, concentrated sulfuric acid, what does it form? Aniline is going to form a complex. Careful. It's going to form a complex with anilinium ion NH3. The complex is plus, and your electrophile, that HSO4 minus, is the electrophile. Further, when you are heating it, it forms a Zwitter ion. This is very important thing. Okay, it forms a Zwitter ion. So both the charges. But here in this case, you are writing the ion in this form, SO3 minus. So here, if you want to show the Zwitter ion, you should make NH4 plus here. So this is your first product. The next, BDC with ethanol. Okay, BDC with ethanol. Whenever you're taking BDC, remember when you're heating it, your benzene is out first, then nitrogen gas is out, HCl gas is out, and what is important, ethanol you're taking, so you will be converting your BDC to your aldehydes. So acetaldehyde is what you get. Now third one, what is the third one? They have given me aniline plus acetic anhydride. Correct na? I told you that day, aniline C6H5. If you write like this, acetic anhydride, in which you are writing a molecule where water molecule is condensed, so the molecule breaks in this way, this hydrogen comes out, and you will be getting C6H5 NHCOCH3. Correct na? COCH3. This is one part, and the next part is acetic acid. This is okay. This is the third one. What is the fourth one? Aniline, BDC with H3PO3 and water. Same thing, almost the similar one. So you will be again getting your benzene, your H3PO2 na? It was PO2, yes. Gets converted to H3PO3 plus HCl plus nitrogen gas. The last one is what? Okay, fifth one is your carbylamine reaction. Correct na? So you will get an isocyanide here plus your KCl plus water molecule. So that's the thing. So key 3 KOH they have given. So I will write 3 KCl and 3 water. So these are the products of the particular reaction. This is just very, very, very important reaction, students. Please practice this. See, easy. So this is again a 5 marks question. If you know all full 5 marks, you will be getting. Next thing is they're asking you to write short notes. So carbylamine reaction, diazotization reaction, Hoffmann bromide degradation reaction, and coupling reaction, and ammonolysis reaction. So basically these are all named reactions. So I already did this name reactions, as I said. Please watch. I did in the preparations and chemical properties. Chemical properties, I did all the reactions. So please watch that, the first initial pages of the video. Please watch it. Okay, so this is a blank page, so watch that. Okay, done. Next one, next question. Complete the following reactions. They have given amide in the presence of reducing agent. So simple na, reduction. So oxygen, what will you do? You will remove this oxygen and add one hydrogen. That's all. Simple. Or CH2 NH2. Okay, primary amine. Now again, this reaction is important, I said na. Yeah, so what they said, complete the following reactions. BDC H3PO2 will become benzene. Same thing I told you, no, this H3PO3 reaction is very, very important. Okay, simple. You are going to just write same H3PO3 plus HCl plus nitrogen gas. These are the products. Okay, then concentrated nitric acid, I said simple, it's going to form 2,4,6 trinitro aniline. This is the product. Easy? Very easy. Next question. These are all important reactions. Please practice them. Why is paranitroaniline? Why is paranitroaniline a weaker base? Why is paranitroaniline a weaker base than metanitroaniline? Okay. So what is the difference between paranitroaniline? This is my paranitroaniline and this is my metanitroaniline. Okay. Now in para-nitroaniline, what are you observing here? Basically, you're in para position. First of all, nitro is strong electron withdrawing group. First point we'll write. At para, this is a strong electron withdrawing group. Okay. What effects are there here? Minus R effect as well as minus I effect. Both are acting. Correct. So what will it do? It will try to decrease, because of this electron withdrawing nature, it will decrease electron density. Decrease electron density. It will not, see, basicity means nothing, ability to donate electrons. So it's going to decrease the electron density here from NH2. So because it is reducing electron density, it's directly pulling all the electrons. That's why para-nitroaniline is a weak base. It's a weak base compared to this. That's what now I'm giving the reasons. So para-nitroaniline is weaker base because strong electron withdrawing nature, minus R effect, minus I effect, decreases electron density, and hence weaker base. So compared to your meta-nitrobenzene. Easy. Now next question. Give reason why trimethylamine reacts with BF3 while triphenylamine does not. Trimethylamine. This is your trimethylamine. One CH3 group, CH3 group, CH3. So I think I'll write the other way, so that in the exam also you can write the other way. I'll show you. I'm writing trimethylamine now. So CH3, N, CH3, this CH3, 1, 2, 3, 4, 5, 6, 7 and 8. Now they asked me triphenylamine. Same thing, 3 rings. That is your PH3, 3 rings with your nitrogen. Okay, done? Now, so BF3 is coming here. So what is BF3? This is a Lewis acid. BF3 is a Lewis acid. Correct? Na? Here also BF3 is there. This is a Lewis acid. So now they said it reacts with BF3. Here what is happening in trimethylamine? This methyl group, whatever is there, it shows which effect? It shows plus I effect. So what does it do? Because of the plus I effect, it keeps releasing. So what does it do? It tries to push all the electrons, and this nitrogen will try to donate it to your BF3. Because that's Lewis acid, it's going to pull the electrons. Correct? But here in this case, phenyl rings, this phenyl ring is showing minus I effect, electron withdrawing effect. It tries to pull the electron density towards it. Then what will happen? This nitrogen, instead of giving this electron to this, it's trying, or phenyl ring is trying to pull the electrons towards phenyl ring because of minus I effect. So in this case, what happens? Here reactivity increases. Here reactivity decreases. That's all. That is what you will write. Okay, done. So here in this case, reactivity increases because of plus I effect, decreases because of minus I effect of phenyl ring. That's why it reacts with BF3. This does not react. Easy. Next question. Why methylamine in water reacts with ferric chloride? Okay, to precipitate hydrated ferric oxide. So methylamine in water. First of all, they are asking me to write a reaction. First of all, let us write. What did they say? They said methylamine. Okay, methylamine is reacting with water. Okay. So what will this form? The bond breaks here and hydrogen goes and adds, and you get CH3, NH3 plus and your OH minus. Okay. Now this is basically, now they said this methylamine, it forms an ion, cation. Correct. Now this ferric chloride, Fe3 plus, okay, so reacts with your OH minus. Let me first write. You get Fe, OH taken thrice, or you can also write it as Fe2O3.3H2O. Let me balance this. This is 2, this is also 2, and this is 6. Now what happens is, here in the methylamine, when it reacts with water, it releases OH minus ion. Correct, na? This OH minus ion. This OH minus ion goes and reacts with your ferric chloride to form ferric hydroxide. Correct, na? What does it do? whatever OH minus ions it has released, it goes and attacks with your ferric chloride and it forms ferric hydroxide. Done. Clear. Now read the question. Why methylamine in water reacts with ferric chloride to precipitate hydrated ferric oxide? Ferric hydroxide or ferric oxide? Hydrated ferric oxide. Why does it form? Because of this reason. Reason is when methylamine reacts, it releases OH. OH goes and reacts with ferric chloride Fe+3 and it forms the ferric hydroxide. That is the answer. You see? Easy. Next question. How will you prepare methyl orange from sulfanilic acid? Methyl orange from sulfanilic acid. What is sulfanilic acid? I want what? Methyl orange. Okay. First of all, methyl orange formula is this. Let us write methyl orange formula. Okay, this is my methyl orange formula. Okay, methyl orange formula. Okay, done. Now what do I take? I need to take sulfanilic acid. Okay, sulfanilic acid is nothing but your aniline with your SO3H. SO3H. Okay, this is your sulfanic acid. Now what happens? This sulfanic acid, now observe carefully, SO3 molecule is already there. Aniline molecule is already there. What should I do? I need to first convert this SO3H into Na group. What I can do? I can introduce a base like sodium hydroxide. When I add a base to sodium hydroxide, water molecule OH from here, H from here comes out and you get a molecule that is this. So this is, I don't have place. Okay, let me erase this. This is nothing but SO3Na. Correct now? Done. SO3Na. This is Na plus and SO3 minus. And here NH2 is out. NH2 is added. Now what else is there? Now careful. Whenever you have aniline group or aniline functional group, first try to convert to BDC. Then it is easy for us to evaporate the sodium, evaporate nitrogen, evaporate HCl and I can add one more group. So try to add HNO2 at 0 to 5 degrees centigrade. Then what will happen to this group? This group will get converted to BDC. The whole molecule, whatever is there, I am writing it here. This group, this whatever SO3Na is there now, SO3Na is there only. I wrote it in the reverse order and this becomes BDC. Now what can I do? I can just carefully see here. This part is ready. Only the second part. I need this ring. Now introduce a functional group which has this. You're trying to add ice cold water to this and you're going to introduce a benzene ring with N dimethyl benzene. You're going to add. When you add to that, careful, both are going to couple and you will be getting methyl orange. Observe carefully, this nitrogen, one nitrogen comes out and this nitrogen pairs. Now see here, no, once again, ice cold water, no, HCl comes out and this nitrogen pairs with this ring and the remaining and you get methyl orange. So this is your molecule, easy. So that is preparation of methyl orange from sulfanilic acid. Okay, next question, let us see. Write the method to prepare a pure sample of primary amine having one more carbon than alkyl halide used. Write the method to prepare pure sample of primary amine. Okay, before we go to this question, careful, understand, I want a primary amine which is a pure sample with having one more carbon than alkyl halide. Oh, easy. First you take alkyl halide. Okay. Try to replace it with KCN, alcoholic. Then what do you get? Alcoholic, not aqueous, alcoholic. So CN. Then I need to convert primary amine having one more carbon extra. Compared to this, the carbon should be extra. So I am going to use lithium aluminum hydride reduction. When you do reduction, what happens? One hydrogen adds here, one more hydrogen adds here. So The carbon chain is longer enough, na? Correct? This is the simple one. X can be anything. This is one carbon. Here there are two carbons. So that is what they said, na? Having one more carbon than alkyl halide. So this is the answer. Easy? Easy. Chalo. Next question. Write the main product when benzene diazonium salt reacts with the following reagent. Okay, BDC reacts with the following reagent. Do we have place next page? No. Okay. First one, HBF4. What does it do? It adds fluorine. So take your BDC. I did one flow chart for this where I took all the reagents. So HBF4. What will add here? Fluorine. So nitrogen gas escapes out. HBF4, HCl goes out. So fluorobenzene. Next, you are going to use Gattermann reaction here where BDC. What is the nucleophile here? Bromobenzene. That is what goes and attacks the para position. C is your hydrolysis reaction. So BDC, when you are doing hydrolysis, you are going to get alcohol. Correct, no? Simple. Alcohol and HCl and nitrogen gases out. That's all. Simple. Chalo. Next question. They're asking. Write chemical reactions. Write chemical reactions or chemical tests rather. Right? Okay. Chemical distinguishing test. Sorry. Okay. They are asking. Write chemical distinguishing tests between the following pairs. Aniline and N-methylamine. Okay, aniline and N-methylamine. Before we go to this big question, let us do this. Aniline and N-methylamine. First of all, aniline, what is the characteristic? First of all, let me analyze. This is aromatic amine and this is my aliphatic amine. Correct, na? So, what can I do? I can take or prefer take it and first chloroform carbylamine reaction. Correct, na? Carbylamine reaction is characteristics for your aromatic amines. So aniline, when I am trying to add my, you get a compound which is offensive smell, that is nothing but carbylamine, which is a foul smell compound. Now same thing when you take N-methylamine, N-methyl-aniline. This is primary amine. No, once again students, this is not aliphatic. This is also aromatic. I'm really sorry. One second. This is also but aromatic primary amine. Aromatic primary amine. This is aromatic amine. This is aromatic primary amine. So here aniline and methylamine, again when I am using chloroform, listen, there is no reaction. Okay. Reason, in aniline the NH2 part gets converted to NC. So this is characteristic for this. I can use this test. Next one. Okay. 2 NH. There is one. And here you have tertiary. If you are adding HONO or nitrous acid or HNO2, NaNO2, HCl, remember this is secondary. So both are reacting, but here you will get an yellow oily liquid, oily compound which will not be soluble in water, but here you get a salt soluble in water, remember that. So this is a differentiation test between this compound and this compound. Easy. Next question, big question. Let's read. Very big question. I need to find A, B, C, D, E and F. We will do step by step. Chalo. An organic compound A with molecular formula C6H7N is sparingly soluble in water. Okay. First topic. It's sparingly soluble in water. And A on treatment with dilute HCl gives water soluble compound B. A also reacts with chloroform in the presence of alcoholic AOH to form obnoxious, here I got a obnoxious compound C. A reacts with benzene sulfonate chloride, that is Hinsberg reagent, to form an alkali soluble compound D. A reacts with HONO to form a compound E, which on reaction with phenol forms an orange dye. Okay, elucidate the following organic structures. Clear? Let's go step by step. First, step number 1. Organic compound C6H7N. Step number 1. Carefully you will understand. It's a 5-mark question. First, to identify the molecular formula given to me is of A is C6H7N. Correct na? When N is there, that means it is a derivative of it is a benzene. It's a derivative of benzene with amine group. Correct? Derivative of benzene, because N is there, benzene ring also is there. They also said it is sparingly soluble. Sparingly soluble in water. It's sparingly soluble in water. What does it mean? It means amine functional group, whatever is there, whatever amine functional group is there, is a primary aromatic amine. Why? Because it has amines are limitedly soluble. Means sparingly means limited solubility. This sparingly means it is limited solubility. So when they said it is limited solubility, means compulsory it is your aniline, because they have a bulky aryl ring, no? It's difficult for them to dissolve. Next, third, they said, that's all, no? A compound. Okay. So according to this, my analysis, A molecule is aniline. Correct, no? Both C6H5NH2. This is step 1. Done. This is clear. Now, then they said aniline is retreating with dilute HCl to give water soluble compound B. Okay. A also reacts with chloroform and forms C. Let us do both the things. Step 2. In step 2, what did they say? A is reacting with dilute HCl to form B compound. Okay. So C6H5 is reacting with my acid, dilute acid, to form anilinium chloride. This is my anilinium chloride. Okay. This is B. This is A. What is this? This is anilinium chloride. Okay. Done. Okay. Done. Now, step 3. They said this B, this A is reacting with chloroform CHCl3 and alcoholic KOH to form C, they said. Correct. What is this reaction? This is nothing but carbylamine reaction. Carbylamine reaction. So take that aniline, take that chloroform, take that KOH, and what do you get? You get carbylamine forms NC plus KCl plus water. Balance it. 3 here, 3 here and 3 here. So this NC is C. What is the name of this compound? It is called isophenyl isocyanide. Correct na? Phenyl isocyanide. Am I right? Done. Okay. This is an obnoxious smelling compound. Okay. This is over. Step 2 is over. Step 3 is over. Then they said here till here this is over, no? Then A reacts with benzene sulfonyl chloride to form a soluble compound D. A also reacts with NaNO2 to form E. Chalo, let us do that. Step 4. Step 4. A reacts with benzene sulfonyl chloride C6H5SO2 Hinsberg reagent SO2Cl to form what? Compound D. Chalo. C6H5NH2 is combining, 2 hydrogens are like this na. It's combining with my Hinsberg reagent. What will come out? Your HCl is out and I'll be getting H5 and NH SO2 C6H5 plus HCl. This is called what? And they said this is alkali soluble. They said, they gave a clue. It is alkali soluble. Easy. What is the name of this compound? This is N-phenyl benzene sulfonamide, N-phenyl benzene sulfonamide. This is D. Easy? Very easy. Now let's go to step 5. Step 5. They said this A is combining with NaNO2 and HCl to form compound E. Right? Now what is this reaction? Basically this is Hinsberg reagent test. Hinsberg reagent test. Now the last one, what is this? This reaction is also what? Simple, it is diazotization reaction. Correct na? Diazotization reaction. Easy. So what will it do? Your aniline is going to combine with your NaNO2 plus HCl. And what do I get? I will be getting BDC Cl plus NaCl plus water. Okay. So this molecule NaCl, this is molecule E, that is your BDC, benzene diazonium chloride. Easy? All are over? No, I should find E na. Now let us do step 6. Step 6, this is the longest reaction actually. Step 6, they said E, a reaction of E with phenol. E is going to react with phenol to form F, and what that is an orange color dye. Orange dye. So basically this is a coupling reaction. Coupling reaction. What is E here? BDC. So you are going to take your N2Cl, you are going to do phenol reaction OH. Correct? Here what is going to happen? The HCl molecule H and your OH and Cl comes out, okay, and you get nitrogen couples with this to form OH plus your HCl. Now this molecule is your F molecule, and the name of this compound is, I'll write here, para-hydroxy azobenzene. Para-hydroxy-azobenzene. Done. This is the orange color dye. Orange color dye. Easy? Very easy. Perfect. So this is what we have to do. Now before we go, let us first write all what are there with the structures. A, B, C, D, E. Correct na? Yes. A, B, C, D, E. What is A now? First one is your aniline. Correct na? Aniline. This is your aniline. I am writing. Next. Second one, B, is your anilinium chloride. Anilinium chloride. Anilinium chloride. Okay. C is your phenyl isocyanide. Phenyl isocyanide. D molecule is my phenyl N-phenyl benzene sulfonamide, no? N-phenyl NH N-phenyl benzene sulfonamide. This is your D. Benzene sulfonamide. Is it okay? Which is alkali soluble. Alkali soluble. You should write the option. Then E is your BDC. Benzene diazonium chloride. Then F molecule is your para-hydroxy azobenzene, which is an orange dye. Correct na? The molecule which I wrote there, I am again writing for you all here. Okay, this one. So A, B, C, D. Before we go to this next question, so I think I have done all. So they asked me to find out. So careful whenever you're doing such paragraph based question, please do step by step analysis, because the examiner will get impressed. Finally, final step, when you do the conclusion, try to write the A with the structure and try to write it with name. So like this, A, B, C, D, E, you're going to write it. Am I clear, students? Easy? Very easy. Chalo. Next question. Give reasons by for the following. Electrophilic substitution reactions in amines take place in aromatic amines. Substitution in aromatic amine takes place more readily than benzene. Okay. First of all, what is the problem here? ESR is happening in amines but not in benzene. What happens in amine NH2 group in aromatic amines? What is its speciality? It has plus R effect. What is plus R effect? It will, plus R effect means it increases electron density on the ring. Okay, it start increasing more and more electron density on the ring. Then what happens? Automatically this will help the electrophile to attack. Electrophile will come and attack the ring because it tries to provide more and more electrons. Electrophile is an electron deficient compound, so electrophile will help, electrophile will come and attack, electrophile to attack the ring. That's the reason. But in case of benzene, no such effect is observed. No such effect is observed. Is it okay? That's the reason electrophilic substitution are more in amines rather than benzenes. Next question. Ethylamine and acetamide both contain amino group, but acetamide does not show basic nature. Okay. Ethylamine and acetamide. Let us write the structure. Ethylamine. Okay. Ethyl CH3 CH2 NH2. This is my ethylamine. So in ethylamine, what did they say? It contains, both will contain amide group. Okay, let us draw amide, acetamide also. B first part, second is acetamide. Acetamide is basically your NH2 linked with your CO and CH3. This is my acetamide, correct now? 1, 2, 3, 4, 5, 6. 6, 7, 8. Okay, now this is my ethylamide and this is my acetamide. Now observe, they said both the cases there is amine group. Here also amine, here also amine. But problem here is what? Acetamide does not show basic nature. Why? This also has lone pair of electrons, this also has lone pair of electron. Now first case. In this case, in ethylamine, lone pair of electrons are present on nitrogen atom and this is plus I effect. This tries to donate electrons. When it tries to donate electrons, automatically the electrons are, or this particular, when it because of the plus A effect, it acts as a strong base. It keeps donating. But in case of acetamide, what happens? There is a resonance which is existing between two molecules. See here, this nitrogen, because oxygen is electronegative, it will pull the electrons towards it and this nitrogen drops the electrons. H, N plus, double bond C, 1, 2, 3, 4, 5, 6 minus C, CH3. Correct na? So now what is happening? In acetamide molecule, the lone pair of electrons, they participate in resonance. See here, lone pair is participating in resonance. So when they participate in the electrons or resonance, what happens? There is no free availability of electrons. Okay, due to resonance, no free availability of electrons. Hence what happened? Hence it's a weak base because it can't donate. Electrons are already participating in the resonance. That's why they can't donate. Hence acetamide is a weaker base compared to your ethylamine. You see, due to resonance, no free availability of electrons, hence weak base. You see, very easy. Show like that, the examiner will get impressed. Next question. Okay, this is a blank page. Blank. Next question. What happens when alkyl halide reacts with AgNO2 and product is reduced? Okay, they are saying alkyl halide you're taking. Okay, so I am using AgNO2 now. Oh, all right. Then what will happen? AgX is out and you will get RNO2. Then they said this this product is reduced. So reduced means I'll take a metal atom. No, reduction is going to happen and oxygen is out and your amine is in. Done. Next, an alkyl halide is treated with AgCN. Okay, no problem. AgCN, again your AgX is out and what do I get? RC. RNC. It is not RCN. With KCN I get RCN. With AgCN I get RNC. Done. This further product is hydrolyzed, they said. Okay, I am hydrolyzing it. Then what will happen? You will be getting primary amine along with your formic acid. Okay. C part. Methyl magnesium bromide, okay, is treated with cyanogen chloride. This is your cyanogen chloride. What do I get? I get along with magnesium, chlorine and PR. That's easy. Very easy. Done. Easy. Next question. Account for the following. Electrophilic substitution in aromatic amines takes place more readily than benzene. Same, I think same. This question is repeated. Same thing because they have the amine group donates. Let us see the next question. A is done. B part. Nitro compounds have higher boiling point than hydrocarbons having almost same molecular masses. You should simply write in terms of nitro compounds. Nitro compounds are more polar because of the oxygen present in them, more polar than hydrocarbons. Hydrocarbons have what? They have hydrophobic ends. Correct na? They have fear of water, hydrophobic ends. So they are more polar than hydrocarbons. Therefore, they have stronger forces. Of what forces they have? They have van der Waals, stronger van der Waals forces. Is it okay? Done. 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 So simple. You just give the answer to the point. Next question. Account for the following. Amino group in aniline is ortho-para-directing in aromatic electrophilic substitution reactions, but in aniline on nitration gives a substantial amount as meta-directing. Okay, simple answer. What is the answer before we go to this question? The answer here is aniline ion, whatever is there, first thing, it gets protonated. Okay, aniline ion, first what happens? It gets protonated to anilinium ion, NH3 plus. This is your anilinium ion, NH3 plus. So this anilinium cation is, this NH2 is OP directing. This is OP directing, but anilinium cation is meta-directing group. Meta-directing. That's why on nitration, whatever you get, you will be getting good amount of meta-nitro aniline. That's what is said. Right. Next question. Aniline does not undergo Friedel-Crafts reaction. Nice. Because aniline is Lewis base and it can form adduct with AlCl3, which deactivates the ring. So how to write this question? It is because aniline is Lewis base which donates electrons and forms addition product with AlCl3 which deactivates the ring. Deactivates the ring. Is it okay? Done. Done. Right. Next question. Write the name of the test to distinguish between ethanamine and N-ethyl ethanamine. Ethanamine. Okay, first of all, ethanamine. What is ethanamine? Ethanamine or ethylamine is a primary amine. Correct, na? This is 1 degree amine. Next, N-ethyl ethanamine. What is this? This is N-ethyl ethanamine. Correct, na? N-ethyl ethanamine is nothing but your secondary amine. So 1 degree amine, do they react what test? Hinsberg reagent test. Correct? This 1 degree amine, they react with Hinsberg reagent test, and when they react with Hinsberg reagent test, they form a molecule called sulfonamide. And this sulfonamide is soluble in alkali. So with this test I can differentiate between primary and secondary. Now secondary amine, what happens? This also forms sulfonamide, but that sulfonamide, this also forms sulfonamide, and this sulfonamide is insoluble in alkali. Insoluble in alkali. So this is where I can differentiate now. So ethanamine primary, Hinsberg, sulfonamide soluble in alkali. N-ethyl ethanamine secondary amine, it is insoluble in alkali, so I can differentiate them both with this test. Next question. CH3CO C2H5 with ammonia. Okay. First of all, complete this reaction. Ammonia. I get amides first. I get amide with ethanol. Further this amide, if you are doing bromine and KOH, so you get 1 carbonless amines. So A is your amide, this one. B is your amine. That's okay. Chalo. Next question. Out of pentan-1-ol and pent-1 amine, which is more soluble? Solubility means I'm going to see hydrogen bonding. Which one will have hydrogen bonding? This one. Correct. Ammonolysis of alkali halide does not give amine in pure state. In ammonolysis, because you get mixture of 2 degree and 3 degree is also formed along with primary. Correct, no? Because it is formed with primary. Because it is formed with primary, I can't get pure state. Why C6H5N2Cl not stored and used immediately after its preparation? Because it is highly unstable. Just one line answer. Okay. Next question. Write the name of isomerism exhibited by different amines. So amines exhibit chain isomerism, they exhibit position isomerism, they exhibit metamerism, they exhibit functional isomerism. All. Okay. So next question. Write chemical equation to illustrate the ammonolysis of alcohols and alkyl halides. Okay. So do I have place? Yes. Alcohols, ammonolysis. So ammonolysis. So which one? Alcohol. First you are going to take an alcohol. So addition of NH3 first. So I am going to use Al2O3 at 620 Kelvin. What happens? First alcohol is getting converted to your amine. Then again you are adding ethanol. So that means one alkyl group. So now 2 alkyl groups with NH. Further you are adding ethanol and one more alkyl group goes and adds, and your hydrogen decreases. This is for your alcohols. This is for alcohols. Then they said alkyl halides. Alkyl halides, same thing, easy. Take one alkyl halide, introduce ammonia 373 Kelvin and remove Hi. First it becomes C2H5NH2. Now try to introduce an alkyl group. Then what happens? Alkyl group increases, correct? NH. Further you are introducing one more alkyl group. Alkyl group and N. That's all. Further, if you introduce this alkyl group to this, it becomes a salt. It becomes a salt. Easy. So both for alcohols as well as alkyl halides we have done this. Clear? Chalo. Next question. Why aniline dissolves in HCl? So why aniline dissolves? Because it first of all, aniline is a base, correct? So this is an acid. So acid base dissolves in acid, no? Say this. Because C6H5NH2 dissolves in an acid to form so it dissolves due to its basic nature. That's easy, very easy. So all small questions, 1 mark questions, 2 mark questions. What happens, simple analysis, you should know the concept. Let us see some more. Oh, so many 1 mark questions. Let's read and make it 1 1 1 1. Do I have place? I have. Let me try. So name one reaction in which primary amines react with CH3. Okay, what is this? Chloroform means carbylamine reaction. Write the IUPAC name of white precipitate formed when reaction of aniline with bromine water. Okay, 2,4,6 tribromo aniline. Okay, write the product formed by Hoffmann bromide reaction of benzamide. Benzamide means 1 carbon less, it's aniline. Okay. Is CH3CONH2 weaker or stronger base than amine? See this is electron releasing group, so it is weaker. Write the structure of the reagent to protect amino group in aniline. Okay, acetylation. Name the product formed when benzene diazonium chloride reacts with H3PO2. Okay, benzene. Name the reaction which is used to convert BDC into corresponding by reacting with Cu halides, copper halides, that is Sandmeyer's. Which type of reaction involves in the cleavage of CX bond in ammonolysis? Nucleophilic. What is the pH during coupling reaction between benzene and diazonium salt? It's around 5 to 6. Write the reagent which can be used to convert nitrobenzene to aniline. Okay, reduction is happening, HCl. How many structural isomers are possible for C4H11N compound? Compound 5. Okay. Name the reagent for the conversion of amide to amine containing same number of carbon atom. Okay, I want the same number, amide to amine. Okay, lithium aluminium hydride. What kind of substitution involved in Gabriel phthalimide synthesis? Nucleophilic. Name the solvent which is used in acetylation of aniline using acetic anhydride. It is pyridine. Acetylation reaction. Easy. So all the questions okay. Please practice all 1 mark questions. This is a blank page. Let's go to the next question. Okay, this is also blank. Oh, sorry, then blank. Next question. Give chemical test to distinguish between the following pairs: aniline and ethylamine. Okay, ethylamine and dimethylamine. So the first one, do I have place? No. Okay. First question, aniline and ethylamine. So what happens? This is aromatic, this is aliphatic. Correct, no? Aniline reacts with bromine water. So basically 3 bromine atoms to get (2,4,6) tribromoaniline. This is a white PPT and HBr. So this is white PPT 2,4,6 tribromo. So next, ethylamine, no reaction. So this is a characteristic reaction. I can differentiate here. Second, ethylamine and dimethylamine. Okay, ethylamine basically can react with alcoholic KOH along with chloroform to get your isocyanide. Correct, na? Isocyanide. And dimethylamine with this, no reaction, because it is characteristic for the primary amines. Correct, na? Yes. Next question. How do you account for the following? Aniline is a weaker base than cyclohexylamine. Okay, let us first understand. Aniline is a weaker base than cyclo. What is aniline? This is my aniline. Correct. This aniline donates the electron pair and it forms a double bond. So, are any electrons available in the ring? No, na? No. Due to resonance, no free electrons are available for aniline to donate, hence weak base. Correct. What about cyclohexylamine? Cyclohexylamine has a pair of electrons, no resonance, hence stronger base than aniline, because electrons are available for donation, na? That's it. Next question, they said methylamine in aqueous solution gives reddish brown PPT with FeCl3. Okay. Second question, methylamine with in aqueous medium. First, methylamine in aqueous medium forms, see this goes and adds here NH3 plus OH minus. Then this OH minus, as we did this earlier, it reacts with OH, the FeCl3 reacts with OH and it gets converted to Fe, OH taken thrice. This is 2 Fe, so this is 2 Fe, this is 3 to the 6 FH. Okay, now what happened here? The OH minus is reacting with Fe3 plus to form ferric hydroxide. Correct, na? So this is what is the reaction. Reddish brown methylamine in aqueous solution forms reddish brown PPT with FeCl3. So FeCl3, that this one is there, no? That's combining with the OH and this is forming the reddish brown PPT. That's all. This is the reddish brown PPT. Easy? Easy. Oh, that's all. Oh, beautiful. That's all. So students, perfect. We have completed. We have thoroughly completed your amines chapter. You have completed amines chapter. As I said, perfect. We did MCQs, we did 1 mark, we did 2 mark, we did 3 mark, we did 5 mark. and we did topic discussion in detail, correct na? Discussion in detail. So I request discussion in detail. Okay, thank you so much for watching. I want all of you to like the video. It took a lot of time for me to do. Please share the video and please subscribe to the channel. Okay, all right, thank you so much for watching and all the best. Bye bye. Thank you.